my mic down there for questions. And away you go, and good luck.
Hello, I am Larissa Dalla Vela. I am from Universidade Federal de Minas Gerais, and I will present about my paper in automatic aesthetic evaluation in generative image models. So let's start out with what based our work. So this paper, APDDV2, it's from last year. It presents a data set, and this data set is composed of 10,000 human visual artworks, and it has for each for the images of this data set, we have 10 aesthetic attributes, and these aesthetic attributes are such light and shadow and color, and these were defined by specialists, and they also evaluated and given scores for these criteria, and they also present a model, which is ArtClip. It is a fine-tuned on clip, which is used to predict the scores on human created artworks for this criteria. So our main contribution is to see whether ArtClip can be an objective metric for AI-generated artwork the same way it's used on human artwork. And so this is an example of APDDV2. So for each line we have an image and the corresponding 10 aesthetic attributes with the scores. Notice that not all the scores has a value from the image, and this is related to the artistic category and they belong. So our methodology is starting like this. So we have the data set and the ArtClip model. And what we do, we take the data set and we make a sampling. We downsample, so we start with 10,000 artworks and we downsample to 500, maintaining the statistical relevance for our analysis. And then this part, we use, for example, you take one image, you pass this image to the image text model. So we get a description of this image. And with this description, we inputted it again on a model of text to image. So in this part, we get the description, and we generated 2 new images, one with the smaller size and one with the bigger model size. And then we use ArtClip to score these attributes for the generated artwork. So here's an example. We start with this image. We pass it to the image text model, and then we have the description. For this image is a black and white portrait of a person. The individual has dark hair and is looking directly at the camera. The background is blurred, focusing attention on the person's face. Notice that the description has a content of style and a part of content and a part of a style. And so with the description, we pass it to the model, and then we end up with 2 new images, one with the smaller model and one generated with the bigger one. And then in the scoring part, we like fill the tables with the corresponding scores for the generated images. So we end up with 3 tables, one with human data, one with the images of the smaller model, and one with the biggest model. And this is part of our contribution with this paired data set of human artwork and the corresponding images of the small and the larger model. So the results, we now make analysis of the impact of the size of the model on the aesthetic score. So we had a hypothesis that a reliable aesthetic evaluator should assign higher scores to human-created artworks. And we see that Janus 1B was the worst scores, followed by Janus 7B, and therefore the human presented better results, which correspond to our hypothesis. And then we make a consistent analysis, and for this we make the average absolute differences between the data sets. So we compare human to the small and the human to the bigger one. And we see that the bigger model is closer to the human. And once we scale up on the model, so we get more parameters, it benefits all aspects, all the criteria equally. And we see that Janus 7B, or the bigger model, has a near perfect matching color attribute. And this suggests that it can replicate the usage that humans make with color. And so to sum up, our main contributions is this pair data set with our human artworks and the corresponding AI-generated images. We tested that ArtClip successfully distinguishes between human-created artwork from AI-generated artwork in an objective and consistent way. We make this different model sizes analysis, and we see the larger model align more with the human artworks, and therefore we conclude that ArtClip can serve as an automated and scalable metric for evaluating computing creativity. And for next work, we are thinking of qualitative evaluation with human users and application in other artistic domains. Thank you, and I'm open to questions.
Brilliant talk, brilliant talk. Has anybody got any questions from the floor? Aha, go over here.
Thank you for the presentation. I'd like to know if you had some kind of manual analysis of the results for the descriptions. If you see, like, if the descriptions are to your content, if they're good, if they could be improved for some, in some aspect, like, I don't know if it was missing something that you think it's crucial for the generation process to get a better result, the image generation process to get a better, more consistent result with the original image.
I have made, actually, I have made an automated analysis of the description, so I get how long is the text and etc. And I have like a visual analysis of the description, and I think it's kind of bizarre because, for example, the data set that I use is Chinese, and I also use DeepSeek, so they are both Chinese AIs, and like they can recognize Chinese characters and like the sentences that is in the image, so it's kind of bizarre, and like they are very detailed about the content, so it has a good quality on it.
May I just yeah, no, I think that's very interesting. And then it just came to my mind the question about like the characters and the images. Then when you get the text-to-image model, it replicates the text also, the characters?
No, they can recognize, but they can replicate. Okay. I don't know why, but...
Okay, thank you.
There you go. Back.
Nice work, and thank you for the presentation. I was wondering if this description would be the bottleneck for the evaluation, because you are transforming a modality from image to a description that you can lose data there, like lose information during the process. What do you think about the design of the experiment about that?
We thought to use the multimodality of the model, but we want to, as most of the models are text-to-image, such as ChatGPT and etc., the ones that we use in our daily lives are text-based. We want to see, to make another analysis before, sorry. So we intend to do this analysis in the future, but for this we need to detect it. So we want to see if we can optimize the prompt or the description, or what terms does it contain that are related to one category. For example, if I want to improve color, can I say like black and white and another aesthetic attribute related to color, I don't know, that may improve this aesthetic category? So we want to make this analysis in the text, so we didn't cut the text from the pipeline because of this.
I've actually got one question. I saw in your paper you had lots of artwork and evaluation of artwork. If an artist painted in the style of an AI, how would it evaluate it? Is it like a false positive? Have you tried looking at that as well?
I don't know, because I think it's very difficult to replicate the style of AI by an artist,
Yeah.
because once you see an AI generated image, you know that it's AI based.
Yeah, exactly. Yeah, yeah.
But for an image to replicate that, for an artist to replicate that, I think it's not trivial.
Mm.
So I don't know, maybe I can.
Because I think for text, when looking at LLM and the writing style of ChatGPT, for example, then if I do that, then it says I'm an AI basically. I can write in that style. But I think if you're painting in that style, if you find a really top-class painter and see if they could paint in the style of an AI, and then see if it fools your system, maybe an idea. But we've got time for probably one question. Anybody got any last questions? Aha.
Still about the description of the images, did you consider adding some tags like the categories they use in cinema, for example, for categorizing images, like close-up or pano, or something more tagging every product?
I didn't think of this. It may be a future work. That's it.
Thank you so much, Larissa. And a big hand of and a big round of applause, please. Thank you. So, for next speaker, Sophia. I wish I had that yesterday, Tuesday, I thought.
Hello, test.
Yeah, all good. So you've got.
Okay, hello everyone. My name is Sophia Lichtenberg and I'm from Utrecht University, and today I will be talking about the creativity assessment scale we were designing for text-to-image prompting. And first, I wanted to talk a bit why we were inspired to do this, because I think as many have tried before, we wanted to do automatic large-scale assessment of it, but then we realized finding a gold standard with human evaluation is really a hard thing. So we were also thinking, going back to what it actually means. And this was like summed up as a question in a previous paper: what is actually the nature of human creativity when it comes to generating images with text-to-image models, and specifically, for example, I don't know if you guys remember like the upper image that was very controversial in the news, which was created with Mid-Journey prompts and won a prize. But I think there are also a lot of space where you can experiment in a nice way, because the other image was an online exhibition where artists were using prompts to play around with the latent space of the text-to-image models and to expose it for like the misrepresentation of Black identities and using it in a creative way. Yes. What literature, and I think maybe many of you might even be better with defining what creativity means, but from the literature, what most people agree on, that it combines some elements of originality and effectiveness, and what that means for text-to-image models is, or what people think they agree on, is that it can enhance exploratory creativity, because you can randomly sample from the distribution that the model is trying to approximate based on the training data, and the direction of exploring that is using the conditional input in cross-attention, right? So there's not really a guarantee that when you try to sample something from that space, it will actually be like something novel. It is really highly dependent on you, like what is the input and the idea of the human, which can be a text or an image, right? So we focused mainly here on the prompt. Yes, and prompt engineering for text-to-image models has also been very much studied before, with many human studies where they agree it is kind of a learnable skill, which requires you, at least back then, early text-image models, where you use very precise vocabulary to explore the latent space and very specific expressing visual features and an iterative process. And it's not really intuitive for humans to describe visual features in a textual form. And another study found that it's really hard for students to do that, but they are actually found that people agree on what they think is a good or not a good prompt. So I was looking into what does psychology do for creativity assessment, and I've categorized it in 4 categories, like the performance-based methods, self-reports, expert evaluations, and creative products assessment. And we were thinking, yes, so it's not really applicable directly to the prompts because they're not really domain-specific, but you can think as a prompt as part of the ideation process. So we thought, okay, maybe it's the closest to like a product out of this ideation process. So we adapted the creative product semantic scale for our use case. And in our previous studies, we have worked on this to find a gold standard. So we used the Midjourney 2023 dataset and the Diffusion DB 2022 dataset, which are now already a bit older, but one of the biggest prompt image collections that exists. And we also wanted to look at different user engagement to find if there is effect in between creativity and the amount users actually spend. So we define this as the product of the time they spend and the log of the amount of prompts, and categorize them in 4 groups, which you can also see here. The distributions, which is maybe interesting because in the earlier, especially the Diffusion DB dataset was a very, very early version of Stable Diffusion, where there were less users, but they have been exploring way more. And actually both datasets are also only for a period of 2 weeks in comparison to the Midjourney dataset, where we had more users, but who explored way less over this time. And we created a dataset based using SentenceBird and use the most diverse prompts by user, and then we used random and manual selection, which led to a dataset of 160 prompts, 80 from each dataset, and we wanted to also control for prompt length, defining that in 3 classes and split that into a subset, into 8 subsets. So, and this is the scale we have came up with. So, as said before, it is based on the CPSS. So these are like bipolar pairs that you have a 5-point Likert scale to assess if you think it is going more towards the attribute on the left or on the right. And we divided here content and style because we saw that a lot of people are experimenting either more with the content or the style elements, and we wanted to assess that separately. The idea combination category stems a bit from Bowden's kind of definition of creativity to see in which way people have combined concept in expected or unexpected ways. And the last one was meant to be more about how people are writing, because many of these prompts are not really natural language, so they're very incomprehensible, and what kind of vocabulary has been used if it was like coherent and readable. Oh, sorry. And we implemented that as a web interface. And we did some pre-testing to see if the UI was working well, if everything was clear. We had a very small pilot study with university students from diverse backgrounds, from arts and also computer science. We did, they had to do 3 rounds with 20 prompts each, so we had 3 annotations per prompt. We did some training before, and they were exploring some example prompts before doing the annotation. We collected also some qualitative feedback, and people had the opportunity to also use Google search for unfamiliar terms. And finally, we also did a small post-study survey. And here are the results. So because we proposed a new metric, we were assessing reliability with the Cronbach's alpha and saw that there was actually quite good consistency for the style and the idea combination category. And surprisingly, the writing category, which I would have assumed would have been easier to assess for the raters, had really bad scoring, and also the content was only in the moderate. But we kept this, except the writing category, which we dropped. And we also looked at the agreement, and there was really low agreement also on writing, especially on the TTI effectiveness. And this was actually meant as an assessment to see if people think that the prompt would be a good prompt interpreted by the model. And I think that's probably very ambiguous and also hard to assess. So maybe there's some confusion. And also style and content depth. And for the rest, we got moderate to high agreement. We also then did some statistical testing for the prompt length and the user engagement level, and saw that length had a stronger significant effect, which was, I guess, not really what we expected, because, yeah, maybe it shows that user engagement doesn't necessarily mean that the creativity scores are higher. Maybe it just means you produce more, but doesn't necessarily mean there is creative output there. And in general, the scores were relatively low. We had only a few that scored high, and the in the upper corner, you can see a table of the average scores by data set. And the diffusion DB, like the earlier model, got slightly higher average scores in comparison. And yeah, we also have some qualitative results. We found that from the survey, the dimensions mentioned before were found to be difficult to answer, which actually aligned a lot with what we found with the consistency, and that a lot of people, like 20% of the prompts that were annotated, people had to look up actually artist names because they were very niche. Yeah, there are several limitations to this. This was very much like an explorative study to find some way to assess how humans would evaluate that before thinking about how we could automate that. And we only, of course, looked at the prompts because the idea was this is the human input and the creative potential for the model and the output. And another thing, these data sets are pretty outdated. Like the prompting from 3 years ago is not the same as how it works now. The semantic understanding has improved significantly, and also it does not capture the full ideation process, but only a part of it, and does not take into account the model interaction and interpretation. Thanks.
Fantastic talk. Any questions from the floor? Anybody? The usual suspect.
Thank you for the presentation. I was just curious about the semantic diversity BERT you said you used to select the most diverse prompts. How does it work?
SBERT is just you generate an embedding for a prompt, and then we looked on how diverse it is, because users do a lot of repetitive prompting, so we wanted to get a selection of more diverse one. So from the selection that we then looked at and randomly sampled at, we wanted to be very diverse and not just the same thing that was repeated and then just added words at the end, you know?
So you select the embedding that is not close to many others?
Yeah, like with cosine distance or based on the embeddings.
Okay, thank you.
I've got one question as I'll sneak in. I noticed your user base was obviously student base, but are you looking at extending the investigation, looking at older people in terms of creativity, people with more experience in a certain field, or whether looking at people who are, say, poets or musicians or artists and things like that? So what's your viewpoint on that?
For For sure. I mean, as mentioned, this was just for testing if the consistency would work for this kind of metric. But I mean, it's not really like valid for like a larger population, right? Like it's not generalizable yet.
Yeah,
So
yeah.
like.
Also, out of your small sample, did you see any gender split? Even a kind of a tiny gender split in terms of responses.
Actually, we had an equal amount of male and female, but I think there was no distance. We have not really looked into it.
Interesting. Yeah. Any more? In the back. I feel like some kind of TV host running around the studio.
Thanks for running over. Thanks for a very interesting talk in an important area. So following up on the last question, did you have any data that spoke to multi-shot engagements? Like we talked yesterday a bit about people refining prompts through successive interaction. And I'm wondering if for expertise in particular, you would see interesting patterns in how the metric evolved as people were trying to refine the way the final image matched up to what their idea was.
That's very much on point, because that was what we were originally interested in, to do some kind of automatic assessment and analyze kind of this interaction and see if there is a convergence. But for that, we needed some kind of gold standard of human evaluation, which were like, okay, we take a step back and think about what could be like dimensions that we can define what creativity in this specific context means.
Got 2 minutes left for questions. Any final thoughts? Also, one final thought as well in terms of creativity. Are you extending as further work? Are you extending your ideas of what creativity is, according to different paradigms in terms of how people define creativity? Or obviously, with this work, have you just gone for an overall best fit idea of creativity?
Yes, I mean, this is very much literature based. I'm a computer scientist, so this is like kind of the proxy I use for it. But obviously you could also think about like, I mean, prompt engineering has been around for a longer time now. We have more experts who have more knowledge, who could maybe be more involved in defining it, yeah.
Excellent. So a big round of applause for Sophia. Oh, we got one more question. Hold your fire. Hold your fire. Who's yeah.
Just, well, first, thank you for the presentation and the topic. I think it's really interesting. In the space of seeing that the newer, latest, and greatest models are doing more reasoning and sort of prompt intervention in a black boxy kind of way, I mean, I think we first saw that with DALL-E 3, where what you typed in was not the image prompt the machine used. How do you think about how these kind of, I don't know, interfering mechanisms sort of change the dynamic as you see this going forward, as models increasingly sort of step in on behalf of people using them instead of just saying, you can do what you want, here you go?
I mean, that is definitely true. I think it would be also interesting to see, like maybe as a future work, to see what the output is and then like have that assessed separately and see how it actually aligns with the prompt. But I think also it has, as I said very first, like at the beginning with the example, it has been used to use these kind of semantic associations the model used to like exploit that in some way, in a creative way, right? But this is not really captured very well with this scale, at least.
Thank you. And finally, a big round of applause for Sophia. So we should have one more talk from, is it Abdullah? There we are. Excellent.
Okay, so Hello everyone, good morning. My name is Marco Volpe and I'm going to present this joint work with colleagues from the University of Leicester. And it is about a work regarding large language models for a change. And this building is, by the way, the University of Leicester, the building where I go every morning when I am in Leicester. What is this work about? We have seen a lot of talks already this week about using large language models for generation or evaluation of creative artifacts. The question that we asked ourselves was, okay, there are multiple large language models. If we want to use them for evaluating in particular, the focus here is more on evaluation. Can we assume that these large language models would agree with each other in their evaluation of creative artifacts? And of course, this falls into the larger scope of automated creativity evaluation, which is important because we know that human evaluation can be expensive, can be time-consuming, and so on. I was talking of creativity evaluation, but of course we needed somehow to focus on a specific creative task, and our choice was the alternative uses test, which is a standard test for divergent thinking used already from the 60s. You probably all know about it, but just let me recall it in one slide. So the idea is that we are given a common daily life object, like a cotton swab, and we are asked to produce as many uses for that object. So naturally, the first things that come to our mind are the normal uses for this object. So for example, you could use it to apply makeup, to remove makeup, to clean your hairs. So that's what cotton swabs are thought for originally. But maybe a more creative person could think that it could be used to apply glue to craft projects, which is still along those lines. So we are still applying something to something else. But if you want, it was not the original purpose of that object. So in a sense, we can say that it is a bit more creative as a use. It is an alternative use already. We can go wilder, and one could imagine that you could use it to replace a stylus for digital devices. Maybe it wouldn't work out of the box, but with some technical adjustments, could be an idea. Back to the research questions, now that we have restricted a bit the scope. So what we wanted to investigate here was if there is agreement between large language models in evaluation of the creativity of alternative uses, first of all. Then, I mentioned here also impartiality. What do I mean? We used these large language models both for generation and evaluation. So one natural question would be, do specific large language models, ChatGPT, favor in their evaluation the alternative uses that were generated indeed by ChatGPT? Reliability is not the main focus here, but of course, maybe we could get that the large language models agree with each other, but their evaluation doesn't seem reasonable. So we also created a sort of oracle, which is our expected evaluation of these alternative uses, in order to make sure that the large language model evaluation is reasonable, at least. And then there is another question which is about methodology, in the sense that we tried different ways of evaluation, different approaches, and we tried to conclude in the end which one worked the best, which one gave the best results in terms of evaluation accuracy. The ingredients that we used in terms of models, we chose these 4 models: GPT-4, GPT-4o, Claude 3.5 Sonnet, Gemini 1.5 Flash, which were some of the most common models, at least at the time of the experiment, so some months ago. And we chose 5 objects to be used in the test: cotton swab, fork, wallet, soap, and paperclip. And how does the experiment work? So first of all, we ask each model to generate 15 alternative uses per each object with different level of creativity. I will explain in a moment how we get that. And then the same models evaluates all the alternative uses, so both their own alternative uses and the alternative uses produced by the other models. In total, we have this data set of 300 alternative uses per 5 objects and 4 models generating and evaluating. Regarding the generation, so what we wanted here, the focus again is not on the generation, so the goal was not to have large language models generate the most creative alternative uses. But what we needed was more having a varied set of alternative uses in terms of a level of creativity, so that the evaluation could be in a way interesting. So we first asked, we divided into 3 classes. Common uses, which we just obtained by giving a simple prompt like create common uses for a cotton swab. Then we moved to the creative class, also very simple in terms of prompting, so create a list of creative alternative uses for cotton swab. So we are not explaining much about what we mean by creative here. Finally, we wanted something that was a bit wilder, a bit more creative. And for this, we used a technique which we call the forceful prompting. This was actually presented in this same conference in a short paper 2 years ago. And the idea was that we can sort of push a model to produce more and more creative answers. So for example, we can ask for a first alternative use, and we get an output from the model. Then we start to challenge the model. Really, is this the best you can do? And we get a second one. I hope this time you put effort into it. And we get another one. This is your last chance. So in the end, we really threaten the model, and we get the final, ideally more creative alternative use. We presented this 2 years ago, so what we noticed by doing this was that indeed there was an increase in the level of creativity, at least in terms of the evaluation of the model itself. So we decided to use this again in order to get the final class of alternative uses, the one that we called highly creative. Based on this, we created our oracle, so our sequence of expected creativity levels for the alternative uses that were generated. I don't go into the details of the oracle, but the idea is that when a large language model evaluates the alternative uses, we would expect that they can be ordered according to the sequence in which they were generated. So the highly creative consider the most creative, the common ones consider the least creative. In terms of the methodology, so we used two main methods, which are scoring, that is, we ask the model to give a score from 1 to 5 to an alternative use, or ranking, that is, instead we give a list of alternative uses and ask the model to order them from the least creative to the most creative. For each of these 2 methods, we also orthogonally tried 2 different approaches. So one was to give the list of all the alternative uses per a given object, for a given object altogether. The other one was have a segmented evaluation. So we create some chunks of these alternative uses, just in order to check whether, for example, for the ranking, the model would be able to order appropriately 60 alternative uses in one shot, or if it would perform better by having a smaller set to analyze. In terms of the metrics, the statistical metrics that we used to analyze the results, we used Spearman rank correlation in 2 ways. So one with respect to the oracle, in order to measure the accuracy of the evaluation. And the other one is the correlation between the models themselves in order to measure the level of agreement between the models. And then, of course, we measured also the standard deviation in order to check if there was consistency, for example, between the different objects or between the different models in the evaluation of a given artifact. So some results. Let's start with the correlation with the oracle. What we got was that all the models achieved a a Spearman rank correlation higher than 0.77. In most cases, as you can see from the table, it's actually higher than 0.9. So we can say that in general, the models were able to discriminate between these levels of creativity that we had in the original oracle. Then we measured the intermodal agreement. You can see here a heat map. Again, I would say that the results show that there is a good agreement. So we have an average of 0.83 of correlation across all the model pairs. In particular, GPT-4o, Claude, and Gemini show the highest agreement with each other. And also, if you look at the consistency range, that is the range of the agreement, it is a sort of a narrow interval band. Another question was about the impartiality, and our outcome in this case is that we couldn't really observe any self-bias. So it is not the case that the model preferentially rated their own outputs higher than the other model's outputs. I put here a table for one specific method. So this is the comprehensive evaluation by score, so 1 to 5 for all the objects, so it's the average. You can find in the papers also the other tables, but the result is very similar. And here, for example, what we see is that the only model that evaluates their own alternative uses higher than the average of the evaluation is Gemini. The other three models, Claude and GPT-4, GPT-4o, are even too fair, if you want, in the sense that their evaluation of their own outputs is lower than the average evaluation. Then another question that I mentioned was about the methods used. So what we observed in this case is that comprehensive worked better than segmented, so that at least for this experiment, of course, it's difficult to generalize, but for this, I think it depends a lot on the size of the data set. But for this data set, letting the models evaluate all together gave better results than segmenting and then reassembling the results. When I say better results, I mean still with respect, in terms of correlation with the oracle, of course. And also, at the same time, we noticed that the scoring method worked better than the ranking. So scoring in terms of a score from 1 to 5. Yes, please? Oh, okay. And yeah, by the way, if you look in terms of which model was closer to the oracle, in some experiment it was Claude, and in some experiment GPT-4o, depending on the type. I put one more slide here, more out of curiosity, because as I said, the goal here was not to check which model would be the most creative in generating the alternative uses, but still, since we have the data, what we got is that in general, Claude is the one that got the most creative alternative uses, both in the average category and both in the average and in the specific categories of creative uses and highly creative uses. And as I said, there is intermodal agreement, so this was recognized also. Let's say the other models recognized that Claude did the best job. Okay, let me just conclude. I think I can skip the summary, maybe. Yeah, but I think it's more interesting maybe just to mention some limitations and future work. So, of course, one thing that we could try to do is testing with a large data set, because this could affect also in terms of the methodology, which one is the best, for example. We used as an oracle, as a sort of ground truth, if you want, the method that we use for generation. So in that sense, this could be refined. We could use a human evaluation, at least validate it with human evaluation. We also just talked of creativity in general terms. We could make something more granular and look at specific aspects of creativity for the evaluation. other statistical measures, of course, and also we did actually some experiments with open LLMs. I don't have the data here, but Fabrizio, one of my co-authors, did some experiments, and it seemed that there was agreement also in that case, especially between models with a similar size in terms of parameters. And then, of course, we could extend these to other domains because the results that we got were specific for this alternative uses test. Obrigado.
Thank you, Marco. Great talk. Any questions on the floor? I should run over with my TV host kind of.
Thanks for the presentation. It was very interesting. I was wondering about the Oracle setup a bit. If you can elaborate, what model did you use? Because you are comparing then these models to the Oracle. You said that in the Oracle you also used some sort of iterative prompting.
Yeah, so let's see, let me see if I have, or maybe just get back to the slide about the Oracle. Yeah, so we used all the models actually in order to construct the Oracle. The idea was that for each model that was generating, we used first a basic prompt asking for common uses of the given object. Then the second class was we asked for a creative alternative use for the given object. Then we used this sequence of forceful prompts in order to get the highly creative class. So when I say an Oracle here, you see there are 12 bars. You can imagine that each of these bars is corresponding to one model for each creativity level. So you have, you can say this is GPT-4 highly creative, this is Claude highly creative, GPT-4 highly creative, and it is an Oracle in the sense that we would expect then that when the model evaluates a set of alternative uses, it reflects this structure here. I have an extra slide just to show an example. Yeah, so here it is for the object fork, evaluation by scores, and you see that all models but GPT-4o in this case align perfectly with the Oracle, so we're able to discriminate perfectly the classes in which each alternative use should belong. There is an exception here, which is what is reflected also in the 0.87 in the Spearman rank correlation that you get. Is that a bit clearer?
Okay, thank you.
Any questions? Here we go.
So thank you for the presentation. Just you mentioned there you're using ChatGPT-4o. Are you using the tool ChatGPT or you're accessing by API? Is there any difference? Because we see that sometimes the tool, they insert some other prompts in the middle, isn't it?
Yeah, no, the model that we used were GPT-4 and GPT-4o. In most tables, that's what I reported. This was taken from a preliminary version on Archive, but
was
yeah,
API, so
yeah.
Yeah, okay.
I've got one question as well. Did you find when you're looking at this research, did you find a really hard limit on creativity when you were doing really strong prompting with every model? Were they all pretty comparable?
So you mean if there is a limit in the iterations that you can?
Yeah.
Yeah, this is something that was observed in the previous paper. So I think it was like 4 iterations, after which we didn't notice any further increase. So we stopped threatening the model.
Because I think also when you think about abstracts, for me, when I think of cotton swabs, I could create little people with different hairstyles. I could create a framework for a boat. I could create mini tortoise and monkeys to carry around. And I think the limits of the model seem to be not going at that level of really abstractism almost. It's almost like taking a use, like makeup, and then making it a stylus and making it something else, or making like the soap, making a soap instrument, but not say using the soap to use as fuel for a rocket, for example. You know, those kind of really abstract, kind of really kind of strange methods. I've got a methodology to deal with that.
So this is something that I don't have the generation prompt here, but I have the evaluation prompt, I think. So what we notice is that actually, if we go further, then the model starts to generate alternative uses that really don't make much sense, in the sense that they're not really feasible. So, for example, use a fork to travel to Mars. Yeah. So that's why we in the highly creative, we try to say things like more creative means closer to unexpected uses, but also feasible, practical. So something like this. And there is the corresponding also in the generation prompt. So we try to at least, if you want, that's something that captures the value side. So because, okay, we want something novel, but on the other end, it still needs to have some value.
On the system. Yeah, putting guardrails and limits on the system as well.
Yeah, exactly. Yeah.
Any last questions on the floor? And you want one final super question. Anybody got something? Something?
Sure. Thank you for the presentation. One thing we've looked at in evaluation of content is sort of the stochastic nature of leaving the model with a temperature that's non-zero. You didn't make any mention to parameter sort of specification with the API calls. Is that something you looked at, where you always wanted like a deterministic output of temperature 0, or you let it kind of be a little stochastic with a higher value, or maybe leaving it at default 1, or whatever it is you were doing?
Yeah, so in these experiments we didn't touch, so we used the default values for the temperature. But yeah, that's also, I mean, I would say maybe it's more interesting on the generation side, but also for evaluation. Yeah, I can agree that it can play a role. Yeah, the temperature.
Okay, I think that's it. And thank you so much, Mark. And a big round of applause. Thank you.
Thank you.
And that's the end of this session. I think we're ready for coffee break, I think, aren't we? Are we close to that? I think we are. Yep.
So during the coffee break and after the coffee break until lunch, we'll have the poster session. The posters should be all or getting set up in the hall, and you'll be able to vote for the best poster. So have a look, think who should win, and then vote for your preferred poster. And then there'll be an award tomorrow. Okay? Yeah. The volunteers will give you some paper for you to put a number. Each poster will have a number. It should be already there. They were taking care of it before or during this session. And you'll be able to write the number, and then they will put in the box, and we will reveal the results tomorrow. Okay? Thank you.
I think you can put up your slides already. Hello, everyone. Are we ready to start? Welcome to this afternoon session on language. There has been a slight change in the schedule, so one of the presentations from the co-creativity session was moved to this slot. So the first presentation we'll be hearing today is When AI Says No, Investigating the Creative Power of Dissent. It will be presented by David Bouter.
All right. Thank you everyone for coming today. I'm a bit sick, so sorry if my voice is a bit scrackly. But yeah, we have a limited time, so let's dive right into it. I'm going to talk about When AI Says No, Investigating the Creative Power of Dissent. So to start off, I would like to sketch a situation with you. So imagine that you're trying to think of an idea, and you're discussing with a friend about this idea, and everything you hear from this friend is, wow, this is the best idea I've ever heard. You should absolutely do this. It's perfect, go for it. When we do ideation like this, we see within psychological literature that this is usually not the best way to do ideation. Usually it is very helpful if a partner actually provides you with some critique, some ways to improve on your work. So we see that usually within ideation, conformity hurts the creative process, and dissent often stimulates it. I've put up a little bit of a definition of dissent, so it's an opinion that is in non-agreement or in opposition of someone. So now I'd like to consider the following interaction. Yeah? This is a conversation that I had with ChatGPT last week. It says, "Hi Chat, I'm a busy freelancer. What do you think of my idea of working on my laptop in the bathtub to increase my productivity?" And the response is, "Hey David, that's definitely a creative idea. And I see the appeal of multitasking and relaxing and maybe even unlocking your best ideas in a warm soak. So I hope I do not need to tell any of you that this is actually a very bad idea. However, ChatGPT does keep on insisting on that your ideas are always great. So this sort of brings me to a question, which is this the best way to interact with AI when we're doing this ideation? And it sort of led me to the conclusion that AI systems tend to show conforming behavior. In the literature, I've also found that people often apply social rules that they usually apply with other people, also on computer systems that even show the slightest bit of human interaction. So these observations led me to formulate a research question, which is the following. In the context of co-creative story writing, does interaction with a dissenting co-creative AI lead to more creative outcomes compared to a conforming AI? And how does interacting with a dissenting AI impact its adaptability? To test this, I did an experiment. So I've put the steps on the slides over here. So I had participants coming into a room. They would get an unfinished story and write 3 story endings. Then they were, in the second step, randomly assigned an AI which would provide them feedback, and this AI is either dissenting or conforming in its behavior. After reading the feedback, the participants would write 3 more story endings to their story, and this compiles an entire list of a lot of stories. To judge whether these stories are creative or not, 3 experts went through this list of story endings and rated each story from most creative to least creative. When the experiments were done, that left us with a list, with a table of all the results. And I would really like to walk you through this table because this is basically all the information from the entire experiment. So you see a lot of cells in red and blue. A red cell represents a dissenting story, and a blue cell represents a story written with a conforming AI partner. The yellow cells show some ties, and I'll get into that later. I'd like to show this with the help of an example. So let's imagine some imaginary participant number 17, for example, who wrote 3 story endings with a dissenting AI partner. So let's say that we have one of the 3 experts looking at one of these stories and say, wow, this is the best story that I've read so far, and puts it on number 1. You can see that it's at expert 1, rank 1. A second expert might look at the same story and say, well, this story is the 13th most creative I've seen. And then a third expert, mind there are 3 total experts, might see the same story and say, this is the 23rd most creative story. You can combine those ratings in a single rating, which calculates an average, which is the 4th column. If you combine these ratings, it might, for example, show up on the 11th most creative story. So if you compile all those ratings from all those stories, from all the participants, you basically get to this table. And if you do an average, you might have averages with the same ranks. So you see that in the yellow cells, there is a dissenting and a conforming story, but they could also be swapped because they're the same rank effectively. So if you look at this table, you might see a slight clustering, meaning that in the higher ranks, you can see more red cells, and in the lower ranks, you can see some more blue cells. This sort of suggests that the dissenting stories are, on average, rated higher than the conforming stories. Especially this is true in the average column. You can show this with an index as well. So I've calculated a p-value, and this p-value basically tells us the likelihood that dissenting stories cluster more towards higher rankings than those of the conforming stories. And you can see that, especially with the average, we reach a p-value of 0.1, which is pretty good. It's not completely statistically significant yet. But there does seem to be a sort of trend that participants produce better, more creative stories when they interact with dissenting AI. To validate the agreement of the experts, I did a short analysis. So you see some scatter plots on how the experts agree with each other. And the rightmost image is basically each expert compared to the opinion of the other. Each dot represents a story, and the red line in the middle is the representation of each expert would have the exact same opinion. And if they would have totally different opinions, all the points would be on the axis. So there is some difference in the opinions of the experts, And during the limitations, I will shortly tell something about that. A second part of this research was about adaptability. Due to the limited time, I would like to shortly brush over this. So I did an analysis with the unified theory of acceptance and use of technology, for short UTAL. You test some determinants. So for example, you test facilitating conditions, social influence, self-efficacy, and with those tests, it's done with a questionnaire. We see that participants do not show a very big preference over one of the system compared to the other, meaning that dissenting AI is possibly an adaptable technology. And the reason we really wanted to know this is you're going to work with an AI that's constantly going to be talking back to you. Do you even want to work with such an AI? So far, the results do seem to show that most people do not really notice a big difference, except for maybe on anxiety and effort. They might experience slightly more anxiety with dissenting AI and slightly more effort with dissenting AI, but that's not big enough to reach any statistical significance. So the findings of the study is that on average we see that dissenting AI does improve creativity by some extent. However, it is not a statistical change, but we do sort of see this majoring trend. Additionally, we see that with the determinant study that participants do not really mind whether they work with dissenting or conforming AI. However, during the qualitative study, we heard from a lot of participants that the dissenting AI did not make them feel more creative. So that's something that could be taken into account when actually trying to develop dissenting AI. So there's some future works and limitations ideas. So some of the future work is obviously going to be about, can we prove statistically significant that this whole idea, this whole concept of dissenting AI is true? And during the study, there were some limitations that can be solved for example, more robust technique, more robust dissent in the AI. And also there was a bit of a problem with the expert agreement because the experts were from some different domains, and preferably you really have all the experts from one single domain that relates to story writing. So you could possibly improve that agreement as well. Obviously this experiment could also be tried with other domains besides writing, maybe with painting or maybe with making music. This whole sort of argument is meant to apply to co-creativity as a whole. That's it. I got some references and I'd like to take some questions.
Thank you, David. I think we have time for some questions. Apparently, dissent spurs discussion, so maybe we have some people disagreeing with your findings. Anyone?
Thank you for your talk. I wonder if you considered having a team of critics with different personalities, some of which are conformists and some of which are dissenters, and maybe even disagreeing amongst themselves, to create something like a brainstorming session as opposed to a one-on-one assistant and creator situation.
And do you mean a team of AIs?
Yes.
Yeah.
It could be the same language model, but you're prompting it with different personality prompts.
Yeah, so I did a lot of sort of research in this whole psychological idea of ideation. So what do we do with humans? And then I tried to think of the best scenario and apply that to AI. And psychology in general says try to get your groups as small as possible, 2 or 3 people, and then do your ideation. However, I do think that a prolonged dialogue with the AI does make this effect way stronger, because during the current experiments, there was, you did a task, you get one round of feedback, and you did another task, which is very limited. I think if you do an experiment where you do a task, you get feedback, do a task, get more feedback, maybe you can even talk back, maybe you can go in discussion that will pronounce this effect way more. So this is sort of minimal, and I do think what you suggest, at least for the whole discussion part, that it will pronounce the effects.
Because I think it would thwart or blunt the hardest part of the criticism. If the LLMs are arguing amongst themselves, you can learn from the argument without feeling that you're the target of their abuse.
Yeah, that could also be true. Some of the feedback that I've also gotten is that some people felt attacked or maybe annoyed. So it's sort of fine-tuning, and how can you show this dissent in the perfect way, whether that's through a sort of devil's advocate way or trying to observe two dissenting AIs talking to each other. Those are all possibilities.
Hello, hello. Yeah. Hey, David, congratulations on the presentation.
Thank you.
And yeah, it was very well organized and a very interesting topic, so thank you. I just wanted to hear your thoughts on maybe what would happen if you had a, I don't know if that was the case, and if it was the case, please let me know, but if you had a more diverse team to both to write the stories and to evaluate them, because I feel like, and maybe I'm wrong here, but I feel like how you interact with with the ideas of an AI system very much depends with your cultural background, right? So for example, we were talking about it the other day, Dutch people are much more direct, and Brazilian people are much less direct on their comments and criticism in general, right? So do you think that it would make a difference for a system? What do you think would happen if we were at more people? Thank you again.
Yes, thank you. Yeah, I think this is absolutely true. My sample size was very biased in some extent because it was mostly people from my social network. So it was all Dutch people, all people from the same culture. And this whole culture thing, and even language at its own, obviously has a very big impact on how we perceive and measure creativity. So the results could look completely different if we, for example, have German-speaking participants or English-speaking or Portuguese-speaking participants. But of course, that's just a limitation. You're going to work with the people that you have. Within the backgrounds, I did try to find people as randomly as possible, so different backgrounds. I've had people who did creative writing, also people who did computer science, also people who had no education at all. And regarding to the experts, so I am using a known technique called the consensual assessment technique, which was written about, and that basically says try to find experts who fit in the domain of the task you are doing. So if you're doing writing, try to find people who studied literature or are writers themselves. If you're doing painting, try to find painters. So I don't think diversity in the experts part is very useful. I think that might sort of increase the disagreement, and that's kind of what I experienced, because I had a linguist, I had a script writer, and I had a student who was doing English literature, which is all very sort of different way to look at writing. I would have preferred to have 3 people who work with English literature, because the story writing task was about English literature. And I think having the participants as diverse as possible is also great, because then you have the most robust answer to your question. Yes.
Okay, one last quick question.
Thank you for the talk and the subject. I wanted to sort of ask if you thought about degree of agreements or degree of dissent, being that if you think about like the extreme edges, you've got a sycophant who's nothing more than making you feel good about everything you ever say, and on the other side you've got an antagonist who's just going to attack you and shoot you down and destroy you. And of course there's that big spectrum in the middle of that, and I feel like that probably has a big factor here, but I wonder how you've thought about that, if at all.
Yeah, I did think about it a lot actually, because obviously if you're gonna go into full sort of attack mode, then people are not gonna feel like there's being said anything constructive. It's only your work sucks, you're terrible all the time. You're gonna get frustrated, and the psychology literature is also very clear about this if we do human-to-human interaction. So there should be this sweet spot where dissent feels authentic. That's very important. The user should feel that dissent is not being forced, but that the dissenter is actually having an authentic opinion about something, and they should feel that the criticism is constructive, so that that they can improve, and that it's not just criticism for the sake of criticism, but it's criticism to try to help you. And finding that sort of nuanced spot is not easy, and I don't think you can just sort of point to it and say that's perfect, but you can approach it. Someone who sees it can probably judge and say, I can recognize this as constructive feedback. And generally, I like to use the term productive conflict when talking about dissent. But yeah, you're absolutely right. You should absolutely fine-tune the knob of dissent.
Thank you.
Thanks again, David. Thanks.
Thank you.
And we continue with Tony Veal, who will be making mountains out of molehills and presenting a paper on abstraction. Not abstraction, sorry, on analogies, right? Oh, abstraction without information loss in analogical mapping, sorry. You have the floor, Tony.
Okay, thank you. Yes, okay. I will be making mountains out of molehills, which is my general approach to things. I'm going to talk about analogy and discuss a resource, a relatively large structured resource that I've built that I hope you will find useful. But instead of starting with a promise, let me start with a joke. Why do politicians take laxatives? So they can speak more fluently. Okay, so it's quite a nice joke. It's built on a metaphor. The metaphor is kind of obvious. If I may be vulgar for just a moment, it's the bullshit metaphor, or the idea of talking shit. But there's also an analogy at the core of this joke. If language is excrement, then diarrhea is fluency. Aren't you glad that this is straight up after lunch? Okay, so that's a traditional proportional A's to B's, C's to D analogy. And if you're interested in analogy and become attuned to analogy, you'll find them in almost every area of human cognition. And that's why they've been studied so extensively for the last 100 years, from Carl Duncker up to Deirdre Gantner, Ken Forbes, and their vast halo of associates, including Paul Thagard and Keith Holyoke, and myself to an extent in my PhD back in the 90s. So I want to talk about symbolic approaches to AI, which is now nearing its sunset as the LLMs are approaching. I think there's light at the end of the tunnel. That light is the oncoming train of LLMs, of course, but so I hope this resource will be useful for people who are interested in structural approaches to analogy, but doing work with LLMs in a hybrid fashion. Okay, so analogy is a highly structured endeavor. Much of the structure that we're using in analogy we're not initially aware of. It's like the iceberg I've shown here, but we map a structure in one domain, the source, to a structure in another domain, the target. For instance, Galileo described the Earth moving through space as a ship moving through the sea when he was talking about why we don't notice objects falling behind us as they drop. The argument that the Earth is moving doesn't necessitate that inference. So we need a lot of structure. The Rutherford Bohr atom that compares the structure of the atom to the structure of the solar system, again, is highly structured, and it supports inference. The key, of course, is structure, but structure requires abstraction. Two structures on the surface are completely different, but they share a common abstraction that allows us to unify them. This diagram here, the classic Plato versus Aristotelian dichotomy of look up, no, look down. We need to do both. Analogies work because they are feature-rich, but they also work because the source and the target share a common abstraction that allows us to map things that superficially look very different indeed. So we need structures that support abstraction and generalization. Where do we get these structures? Back in 2005, I thought I'd found a rich mother lode of structures in a resource called HowNet, which is a Chinese-English style of WordNet, in which words are given semantic definitions in the form of conceptual graphs. And back then, I showed how you could map, using structure mapping, the semantic definitions of different words. This example is probably the best example, but it's not at all politically correct or pleasant. We have the definition of a blind person. Notice that all of the labels have Chinese as well as English. And the definition of a lame person. Notice how they are isomorphic, structurally isomorphic, allowing us to see that a lame person is to a blind person as looking is to walking, as legs are to eyes, right? Now, the interesting thing about resources like HowNet is that they're full of structures, but the difficult thing is that they're not always full of the structures that you want. It's the old joke about KGB cars. They're very comfortable, but they don't always take you where you want to go, right? And the structures here don't always take you where you want to go. So, back in the 90s when I was doing my PhD, I was intrigued by a metaphor from Umberto Eco in one of his pieces for La Repubblica, where he described the war between operating systems as a religious war, Mac users versus PC users. So I handcrafted these domains. On the left, we have the domain of Microsoft Windows, and on the right, we have the domain of Catholicism, and you can see that the structures have been designed to isomorphically map. Now, in isomorphic structure mapping, a la Deirdre Gentner, the relations map literally, while the nodes connected by the relations map non-literally in an isomorphic one-to-one mapping. That's really important. That's the core of structure mapping, which is essentially a largest subgraph isomorphism problem, which makes it NP hard. But, you know, you can't really go around designing structures by hand like that on a large scale. Now, so what I've done instead to build a resource that I'm unveiling today is I've taken all of the work that I have fruitlessly put into symbolic AI over the last few decades, and which is now obsolete, and tried to get a last hurrah out of it. I've been building resources for years to help me do story generation and metaphor generation, and they're all relatively flat. Triples in the semantic triple sense. So we have triples like laboratories conduct experiments and scientists work in laboratories, or that congregations conduct worship and priests serve congregations. And I want to take these flat molehills and build them into structural mountains automatically that will support structure mapping. So you'll see the little icebergs here. The two flat statements on top are conflated structurally to give us quite a nested structure that combines the meaning of both. And on the right, we do the same. Now, those structures aren't isomorphic because even though they have the same shape, the relations don't match literally. But we'll see that with abstraction, they can be made to map literally. Okay, so this is a simple little trick. It's a representational trick. If the relations have to map literally and the arguments can map non-literally, then we need to rewrite the expressions, moving specific parts out of the relation part of the structure and into the argument part of the structure. So this is abstraction without information loss. So we rewrite these structures to get, by working, perform scientists some work for a laboratory that conduct experiment. Notice how the idea of working is now in the argument position, working and work. And in the same case, by serving, priests perform some service for a congregation that conducts worship. Now these structures are isomorphic and mappable in structure mapping, and we get a richer mapping as a result. Not only do priests map to scientists and congregations map to laboratories, but we also get work mapping to service and serving mapping to working. So abstraction without information loss allows us to do structure-rich analogy on a large scale. We just need to build these structures. And the paper describes how we build them. I won't have time to go into detail. But once we've built them, the database has about a million of these structures. So it's very useful for those of you who are interested in working with structural analogy or who have students who want to work with structured analogy. You now have a resource to do this. The resource supports tremendously efficient retrieval and mapping. In fact, we can map the representations at the string level without ever building graphs out of them, which makes it even faster. So first we have a definition for taking a representation and assigning a structural richness score to it. And basically we're counting the nesting in the structure, and we get a richness on the left for 3.046 and a richness on the right of 5.046. So the structure on the right is richer than the structure on the left. This is important in structure mapping because Gentner posits that when you map two graphs, you map the structurally richest core of one to the structurally richest core of the other. And then you start mapping everything else on an ad hoc basis. She calls this the systematicity principle. And to do that, you need a measure of structural richness, which we provide here and describe in the paper. Now, once we have a measure of structural richness, we can then begin to measure the quality of different analogies by simply summing the structural richness of the structures for one domain that map to the structures in another domain. So we simply sum over these scores, And for instance, when we're looking for an analogy for science, we find that analogies, structures for religion and art score highest because they have the richest structures that map to structures in the domain of science. This is the essence of analogical retrieval, which is a core part of using analogy. If you can't retrieve an analogy, you can't use an analogy. Now, abstraction, I think I've passed it by very quickly. I should indeed wrap up. Okay, so with abstraction, we simply take the argument positions and replace them by numbers. And in that case, these two structures will not be mappable, but these two structures will. And we use the templatized structure as a retrieval queue to make fast retrieval of analogies, extremely fast, even when a database of 1 million structures. Okay. Now, let's characterize this database. It's, as I said, it's built out of these ad hoc representations I've been building for 30 years, and this is a last hurrah to get some value out of them and hopefully give some value to the community. So the database has structures for 9,000 different concepts, or over 9,000 different concepts. And it has 1.7 million mappable structures in that database, spread across those 9,000 concepts. And this is the distribution of structures by richness. We can see that there are, for a minimum value of richness of 2, there's an average of over 2,000 possible analogs per concept. And if you want an average richness of 6, then there's an average of 40 analogs per concept in the database. So this tells you that there are not only structures in the database, but they are inherently mappable. They're not unique one-offs, but they are generalizable to the same abstractions to support complex analogy. Now, the point I want to make in closing is please check out the resource itself. There's a description of how to use it and its structure. The paper will tell you the algorithms for getting the best value out of it. But I do hope that people won't go down the rabbit hole of doing purely structural analogy like we've been doing for the last 30 years, but you will use a structure-guided approach to structured analogy in the context of LLMs, where we get the LLM, we prompt the LLMs with structures, and we use isomorphic algorithms to detect that the structures provided by the LLM are indeed valid analogies. So for guided analogical reasoning in an LLM, we will use the LLM's inherent power, but structure it and guide it using the pre-existing structures in our database and the algorithms for using them. And that's all I have to say on that. Thank you.
Thank you, Tony. Okay, we have time for a few questions. Yeah.
Can you go back to that Q formula that you have there? Yeah, I think that one. Can you say something more about that? I'm trying to understand. Or what does that beta stand for?
Oh, I'm glad you asked, because I forgot to mention it. So thank you very much. Obviously, the beta. Okay, so the summation symbol there is summing the richness of all of the elements, all of the structures in the source domain that have analogs in the target domain, which is what you want. Now, it may be that analogy is composed of a great many flat structures, which is not an interesting analogy according to the theory of analogy. It may be that your analogy is composed of a very small number of highly structured elements that map. That's a much preferable analogy. That analogy exhibits what Gentner calls systematicity. So the beta there is a nonlinear element to the formula that rewards rich structures, so that this formula will give you a good score for a handful of highly structured elements that will be competitive with an analogy that gives you a great many uninteresting structures. Obviously, the bigger beta is, then the greater emphasis you are placing on the systematicity principle, and beta is 3 by default. So we're really summing over the cube of the richness of the individual mappings between two domains. But if you want to prize systematicity even more, you can make beta larger. And if you want to remove the systematicity principle, you simply set beta equals 1. So the formula and the algorithm allow you to put as much emphasis on Gentner's systematicity principle as you care to do. If you leave beta equals 1, then you'll get very poor analogies where you have lots and lots of little flat structures mapping to each other, whereas if beta is high, then you'll only get analogies where you have quite a complex graph structure mapping between the source and the target domain.
Thank you, Tony. I have a question myself. Is Atlas actually linked perhaps to any other known ontologies or lexical semantic resources?
No, it's entirely homebrew, but it is made out of a witch's brew of different resources that I've built over the years. I suppose it could be linked to DBpedia or to a knowledge graph like that. I think anyone who uses DBpedia will find it very disappointing as a source of structure, and you certainly couldn't do much structure mapping with it. So this is more of an antidote to those structures than a complement, but I don't see any reason why you couldn't take those structures and map them semi-automatically to an existing knowledge graph like DBpedia or an ontology of your choice like Psych.
Okay. Thank you. I think we have to move on. Let's thank the speaker again. And the next talk will be on code names, more specifically a development and teaching framework for code names, the game. And it will be presented by Dan Ventura, whom everybody knows.
Okay, thank you. I didn't realize that this was the Hawking Our Wares session, but it is. I am now going to try to convince you that the resource that we built is at least as cool as the resource that Tony built. It's probably a hopeless task, but here we go. This is work done with Robert, my student that I talked about last time, who just had the baby, and another collaborator, George Spendlove, who some of you may know. He was at the conference last year. He will be here next year, but he couldn't be here this year. So I'm giving this talk. Way to think about this talk, or the way we thought about what we did here, is very generally you can think about AI agents as these agents that live in an environment, and they act on the environment, and the environment acts on them, and you have this loop of interaction going around. And a lot of traditional AI problems, the environment is very well defined, the actions are well defined, the results of the actions are well defined, and that's why we're successful at doing a lot of things we do in AI. We can think about creativity. One way to think about creativity is as an agent exploring a very large, often not very well-defined space, and trying to act in ways that produce something creative or some creative result or something like this. So the metaphor kind of works, but the problem is the environment is now not well-defined. The way to measure the results of what happens, the actions that you can take in the environment, all of these things are very much less well-defined, and so it's very much more challenging. And one of the big challenges, of course, is evaluation. When we try to evaluate, as everybody knows, creative things, there's a lot of subjectivity involved. There's a lot of concepts that are not so well-defined, maybe even ill-defined, maybe even people can't agree on what they might be. And so we have thought about how can we sort of ameliorate this a little bit, and our proposal that we made a couple of years ago is some of Brad's work is competitive language games. Competitive language games are nice because they are somewhat more constrained than other kinds of creative tasks, and therefore a little bit easier to get our hands around, but still quite challenging enough to give us many problems, which is perfect. It's kind of a sweet spot. And so that's the sort of resource we're thinking about building, and the sort of thing we're trying to convince people to this space to play in. And one language game in particular that we focused on that has a lot of these properties and is really nice, it's popular, it's easy, but it's also very complex, is the game Codenames. How many people in here are familiar with this game? Quite a few people, and then some people are not, so let me quickly explain it to you. It's a very It got very famous a few years ago. It won a lot of design awards, or a lot of game awards. It's very fun to play. You play in 2 groups. There's 2 teams. On each team, there's a spy master and at least 1 guesser, and there can be as many guessers as you like. And the goal is each team has a set of words that they need to guess. The spy master gives clues. The guessers try to guess the clues, or guess the words, and whichever team guesses all of their words first wins. There are also a set of neutral words that you shouldn't guess, and there's 1 assassin word that if you guess, you immediately lose the round. So if you're a guesser, you see this grid of words on the table, and you have no idea which ones are the ones you should guess. You just see this. And some of these words are your team's words, but you don't know. As the spy master, you see this. You have extra information, and so you know you're the blue team. You're trying to get people to guess the word ambulance and plane and some other words. And at the same time, you don't want them to guess button and carrot because they're neutral words, and you don't get points for those. And you really don't want them to guess doctor and poison because those are the other team's words, and you're helping them win. And you really, really don't want them to guess this one special word that's an assassin word that will end you the game. So as the spy master, your job is to think of word clues. You can get a single word that relates to the blue words and at the same time doesn't accidentally make people think about the red words. So you come up with these possible things like injury or emergency, and you think, well, those things make people think about poison and doctor as well, so we shouldn't say those clues, but maybe something like vehicle is a good clue because planes and ambulances are vehicles, so you say that, and you also add a number, which is how many of your words you think are related to this clue, and then the guessers can try to guess that many words. As long as they are guessing correctly, they get to keep guessing. And that's the game. It's a really fun game. It's a social game. It's also very easy to know when you're doing a good job because you win. And that's easy to measure, and that's kind of the point. So we thought, can we use something like this to make building creative agents more accessible to people and more tangible in the sense of measurement and things like this. And so we built a resource to do this, and it's just an online version of this game with some resources that I can show you. I'll point you. You can look at the code later. Some design patterns and things that are sort of design decisions and choices that we had to make this resource. And we hope that we can foster a community as well to make this a thing. And the resource that we built is a code base that includes a server that runs the game, a user interface that you access through a browser so you can play the game. You can get on and play just as people, just as you normally would, just on the web. And it also includes a Python client code base that lets you build either spy master agents or guesser agents, or both, so that you can play any combination of people versus people, people versus machines, machines versus machines. You can do it however you like. And the user interface is fairly simple, but it has all the elements that you need. You have the blue team, the red team. You have information on the side about which team is guessing, which role this person is playing. You write down the clue. If your role is guesser, you don't have the colors, of course. And so you can just play this or build code to play this very easily. And you can get started really simply because the server is running at BYU already. You can download the client code base, and you can run it right out of the box. We have a very poor spy master sort of baseline agent included, and I think also a guesser agent. They're both not very good, but they're there. Or you can implement your own clue-making function in Python, and that's all you have to do, and now your agent is playing the game the way you know, whatever smart thing you figured out. And thinking a little bit ahead, you might even imagine building chunks of code that do things like associate words. This is the kind of thing Tony's talking about. How do I make interesting mappings or connections between words that will help people guess, right? And this idea of relating words in interesting ways is a very general, abstract idea. And having thought about it in this context, you might take those relational ideas that you've come up with and apply them in a different context altogether. And this just lets you start thinking about the idea of relating words. Oops. Oh, I think I already. Wow, I'm doing this. Sorry, don't know what happened. I told you there was a very simple Word2Vec based agent already available, 2 agents there that doesn't work it's not meant to work very good. It's just to let you see how the code works and have something that will run out of the box, and you're meant to replace it or use this as a baseline to compare against. We wanted to think about how can we introduce this, evaluate this, make use of it, and we thought last year at the conference, Brad and Robert ran a workshop on the first day using this in sort of a research kind of context. So they had a code jam, and the idea was to introduce people to the problem, introduce people to the code base, and get feedback about how well it worked for them, and also get them talking about how to build agents to play this game well and what sort of strategies would work well. And so they had a code jam that sort of people would build these agents and then they would demonstrate them and people would critique them, and it was pretty successful, and we got a lot of feedback on how to make the resource better. I already told you all that. The outcome of the workshop was pretty great because we didn't get a huge community going yet, but we saw that it could work, and we improved it. And we took that resource, having improved it, and we decided, let's use it as a pedagogical tool too. And last winter, just fairly recently, in my computational creativity class, which is a grad class, I had 25 students, and we decided, I'd never done something like this before. Tony did something like this several years ago. He was talking about introducing CC to students by having them build chatbots. And this is sort of that sort of idea, but we were going to have them play this game instead. And so the goal was twofold: introduce students to the idea of building CC agents and introduce students to the concepts of CC. And we're trying to get both things to happen. And it's a lot to do in one semester, but, and in fact, this part of the class only took 5 class periods, like 5 75-minute class periods, so it was very quick. But it was pretty successful. This is how we did it. In period 1, we talked about this framework that we were talking about and about the game. Then we talked about, in period 2, some papers that describe building different ways to think about building CC systems. And we had the students read these papers, and we discussed them in class. And it was a very fire hose, quick introduction to the ideas, but we want the students to start to think about, okay, how can I think about the idea of building this agent to play this game in the context of these things that people have been thinking about generally about how to build CC systems. And then the next, oh, that's just a picture. This is the kind of mental model that we want them to build, maybe, and then think about how do I implement these, at least some of these pieces in my Python code so that my spy master agent can be very clever. And to make it fun and compelling, and also to give the students feedback about how well they were doing, as well as give us feedback about, meta-level feedback about how this whole idea is working, we played 2 tournaments. After those first 2 class periods where they were introduced to the code base and introduced to some general CC ideas, they had to have already built an agent to be the spy master, for which they would be the guesser. And this is an NCAA tournament college basketball bracket, which is the wrong bracket. We, of course, didn't do this. We did something like the World Cup because it's much cooler. We had 4 pools of 6 students, and they all played each other in the pool, and then the winner of each pool went to a knockout round with semifinals and finals. And the class, and we played all the pool games in parallel, but the last rounds, there was everybody watching, so it was quite exciting. And the way they played is they would build the spy master agent, and they would be the guesser for that agent. And so they would play against another person who had their own spy master, and they were the guesser. And so that was a team of 2 against a team of 2, and it was partly them and partly their AI, and then they had this competition. The first competition was fantastic because in only 1 week they had built agents that worked, and we were able to run this thing in 75 minutes, which I had no faith we'd be able to do. And the coolest thing, besides the fact that they enjoyed it a lot, was the guy that won had figured out a very clever way to cheat the game. We hadn't told them they couldn't cheat, we just introduced the game, and he figured out a way he built an agent that would give him word clues that were code for which location in the grid were the words. He almost lost a game because he clicked the wrong location. But that was the only weakness in his strategy. And he came right in and said, I'm going to win this tournament. There's no question I'm going to win this tournament. And he did. And then everybody had to say how they did it, and he was kind of sheepish to admit that he was cheating. But it was really clever cheating, and also hadn't been explicitly disallowed. We explicitly disallowed it for the second tournament. But I thought it was really clever. That was cleverness for the student, not the agent, but it was really cool. In the second tournament, what was cool about that is the competitions were much more even. People had done a lot. In another week, their agents were very much more sophisticated. And some of the things that they did were very clever. For example, one student built a second agent that would try to act as a guesser for the spy master before they got the clue, and they would play the game sort of in the agent's head to see if the spy master and that agent guesser would do a good job together, and if they picked the words that worked together, those are the words that got filtered out. So they did some fairly sophisticated things in a short amount of time, and the competition was much more even. It was really quite well done, I thought. There's still lots and lots of things. The students still could be much more clever than they were, but in a lot of ways it was very successful. We also asked the students afterwards questions about how well this, okay, there we go. How well this longitudinal sort of approach helped them between the two competitions. We asked them questions about how creative they thought their agents were, and we asked them questions about how well they thought this resource that we were giving them helped them learn things. And the results, you can look at them more in the paper, but they were pretty satisfying. They were pretty good. This is a 5-point Likert scale, and like these down here are over 4. So this is about the resource. They really liked the resource. They weren't so convinced about some of the values of the things they created, but that's to be expected. They were pretty happy with the longitudinal aspect of getting them to learn some things too. And that's pretty much all I want to say. I just want to mention, I just want to reiterate that I think language games are a really powerful tool because they're hard, but they're not too hard. They're really fun, and they give us the ability to get our hands on something, on a problem that's not trivial by any means, but is measurable in some tangible ways, which is nice. And I found this paper just a little while ago. Somebody else is pushing language games. This is a person from DeepMind as a Socratic learning method. So I think they're a really interesting thing to think about. This, interestingly enough, that's supposed to show you a website. Anyways, the website's in the paper. You can go get the code base and play with it, download it, and go with it right away. Anyways, I'll stop. I'll give you some time for questions if there's questions. Thank you.
Thank you, Dan, for this interesting talk. We have time for questions. Mm-hmm.
Thank you for the presentation. Now, often when I play Codenames, we're playing with multiple guessers at the same time. So you have one spy master and multiple guessers. And there's often a quality where, as a spy master, you have to think about the, not only do you have to think about what associations there are, but you also have to think about how your guessers will interpret that. And there's an additional, I guess, state component involved with that. And what are your thoughts on extending this to, or extending the states of the spy masters, or to kind of either frame the spy masters' associations in a group of guessers frame or perspective?
Yeah. So is there a question in there? Did I miss a question?
So the question is, what are your thoughts on that aspect, right? Is
Oh,
there anything there?
yeah, that aspect is why the game is fun in a lot of cases, right? You think you have this really great clue, and your team starts thinking about all kinds of stupid stuff that you had no intention that they think about, and they talk themselves right. Even better is they immediately know what you're talking about, and then they talk themselves out of it and guess wrong, right? And even if you have only one guesser, they can do that, right? So I think what you're talking about is something like a bit of a theory of mind, right? You have to make a model of your partner or partners and color your strategic clue creation to fit that model, right? This is why good friends or people that have known each other for a long time are good teammates in this, and strangers are less good teammates in some cases. And actually, maybe sometimes it's the opposite. Strangers don't do all the weird stuff, and so they just think more on the surface like each other, and they make better. Anyways, this theory of mind thing this is a perfect thing to be able to study that, right? You can build as sophisticated a spy master as you'd like. You could build as sophisticated a guesser as you'd like, and they can include theory of mind components. In fact, the example I gave you where the student built an extra agent was kind of like that, in the sense that before they would have their spy master give the clue, they would test it out on this other guessing agent and see the result of it. And if it wasn't good, they would come up with a new clue and try again. And they might come up with 10 or 15 clues in the 30 seconds they were allowed before they found one that was fitting their like admittedly unsophisticated model. But I think you can do some really sophisticated things here, which is why it's cool, I think. It's a really fun game. It's very simple, but really hard also. Really good.
Other questions?
In your before to last slide, you mentioned this paper on the Socratic learning or something like that.
Oh, the Socratic learning paper that I had?
Yeah. I'm interested. I was wondering whether there is maybe some play element in that sort of Socratic questioning and answering. Have you thought about that? Or can you say more about it?
Well, I just barely discovered that paper, so I haven't thought deeply about it at all yet. I just caught my attention because it was also about this kind of idea of using language games as something interesting. Right? So I need to think about it more before I can say anything about it. Just threw it up there as, look, we're not the only people thinking about this. And I would like other people to be thinking about this. I think there's a really rich playground here. And the barrier to entry is quite low, and we've made it even lower by providing this resource. So you can just jump in and start playing with it right away, either as a pedagogical tool, which I think is really great for. It might be better for that than anything else. But I think there's a lot of interesting research questions you can answer playing this game as well.
More questions?
Hi, thank you very much. I'm wondering if you have any intuition or results on how good AI is at playing the game versus humans, in the sense that, sort of following up on the theory of mind idea, I would expect that at least it's possible that an AI spy master with AI guessers sort of sharing the same brain would have a possibility of being very, very good at this because they're the same person in a way. Is that accurate, or I don't know? Do you have it? How good are they?
It's a really, really great question. It's hard to say because you kind of have to build all possible AI models and test them all to see which are the good ones. There's a lot of really bad ones, I'll say, and in the paper that Brad did a couple years ago, he did a little bit of that kind of stuff. Like he built several different kinds of models and several different kinds of guessers, and he paired them. Right? You can do that kind of stuff really easily here and check that. I haven't become worried yet that people are going to be superseded by AI with this game anytime soon. But I agree with your idea that in theory it seems like they might be, but this seems like a trickier game than, I mean, it sounds a little bit silly to say in some sense, but it seems in some ways a lot trickier game than a game like Go, which is combinatorially very complex, and we thought the AI wouldn't beat humans at it for a long time, and all of a sudden, This seems less well-defined and trickier and more subtle in some ways that aren't combinatoric. So, I mean, computers are really good at combinatoric type things. I'm not sure that they can leverage that anyways to beat us at this game. People that are really good at this game can get 3 and 4 words at a time. And if you do that, you only have to guess 9 or 8 words depending on if you're first, second team. So if you can win the game in 3 guesses or 3 rounds, that's really high level play. And I don't think any AI that I know of are close to that yet. But there might be some. I don't think so.
Thank you. Any other pressing questions? If not, then let's thank Dan again.
Thank you.
I'll just say I particularly like the evaluation part, which you mentioned at the beginning of the presentation, especially for students in this student pedagogical context. They are used to looking at precision recall tables, and then here it's about winning. That's really neat. Yeah, cool. The last presentation in this session will be presented remotely by Mohammed El-Zohbi. Mohammed, can you hear me? Great. Then perhaps if you can say something so that we see that we hear you too.
Can you hear me?
Yes, we do, don't we? So yes, if you can share your screen, and then the floor is yours.
Okay.
Excellent. We see your slides.
Can you see my screen?
Yes, we do. So feel free to start whenever you're ready.
Okay. Okay, hello everyone. My name is Mohammed El-Zohbi, and today I'll be giving an overview of our paper titled Poems to Lyrics, Automated Rephrasing with Beat Alignment, authored by myself and Professor Richard Zhao from the University of Calgary. So both poetry and song lyrics are expected to display creative qualities in a sense, but they differ in their structural and rhythmic requirements. Unlike most types of poetry, lyrics should align with musical components. In this work, we focus on the task of rephrasing poetry lines to align with a desired beat. Many prior studies focus on the rhyme of poems or song lyrics, but they often overlook the rhythm component. Also, the works on rhythms mostly focus on aligning stressed and unstressed syllables with the musical tone and pitch. However, in this study, we were interested in the alignment of lyrics with the percussion, where beats and rest should be aligned somehow with the language, which we see as a gap in the literature that we are targeting in this work. So this work is an extension of a previous work of ours where we proposed a substitution task where, given a lyrics line, the model needs to insert or replace words such that the replaced or inserted words follow a given beat pattern. In this work, we propose a rephrase task where, given a lyrics line, the model needs to rephrase it such that it aligns with a given beat pattern. Now, ideally, we need a parallel data set of poems and their corresponding alignments with beat patterns, maybe made by experts, but this is up to the best of our knowledge. It is not available and it's expensive to create. But can we infer the beats from the language itself? So our beat alignment strategy builds on earlier research on the perceptual beat locations in spontaneous English conversations, where participants were asked to tap their fingers in synchrony with where they perceive beats in spoken words. The previous works concluded that the tapping was happening on the vowel onsets within the syllables, so at the transition from a consonant to a vowel. As a result, we if we know the places of vowel onsets, we can align the beats with them. So given this, we developed a grapheme to beat model in our previous work that transform English script to beat sequences, which consists of a grapheme to phoneme model, because English is orthographic deep language, where there is not perfect match between like mapping between letters and sounds. So to get the consonant vowel sequence, we needed to get the corresponding phonemes first, and then the phonemes can be translated to beats in a rule-based manner. So now we can benefit from the fact that we can infer the beat sequence from the English lines. All we need is a poetry paraphrase dataset that preserve some poetic qualities in the originals, but this is also not available. So for this reason, we created parapoetry, which is a large-scale dataset matching human-written poetry lines to 5 rephrases automatically generated using GPT 3.5. So we started from a processed version of the Gutenberg poetry dataset and asked GPT 3.5 to provide 5 rephrases, making sure to preserve the poetic qualities such as poetic devices like metaphors, similes, hyperboles, and so on and so forth. We ended up with more than 4.6 million unique line rephrase pairs, which we made available for researchers. For this work, we chose to fine-tune a pre-trained BY-T5 model, which is a token-free model. Unlike the other transformer models, this model tokenized sentences into character sequences instead of words or subwords, which will give us granular character-level precision over the sequence. In fine-tuning BY-T5, we will benefit from the encoder-decoder structure of T5, the fact that it is trained to regenerate masked characters in an autoregressive manner. So we trained the BY-T5 model on rephrasing poetry lines to match a given beat pattern in the following manner. In parapoetry, the dataset that we created, the original lines were written by real poets, unlike the generated rephrases. So to help our model be more biased toward generating human-like lines, we augmented the dataset by swapping the rephrases with the originals, so that we avoid the bias towards automatically generated output. And then we filtered out very long and very short lines. We also did a reduction based on lexical dissimilarity between lines and the rephrases by using the pink scores to remove data with minimal substitution and potential garbling. We then trained the model to rephrase a poetry line guided by the beat pattern of the target. So, and the beat pattern of the target is generated by the grapheme to beat model that we introduced earlier. The model will then learn to minimize the loss given the target. At the inference level, the user can give the model the lyrics draft with the desirable beat, and then the model will rephrase the line to align with the beat while preserving poetic properties in the original. So to evaluate, we use automated evaluation metrics to measure sentence similarity. We used sentence BERT to encode the original and the rephrased line. And also we used cosine similarity to measure the similarity between their embeddings. We also used the pink score to measure the lexical dissimilarity as a descriptive metric to show the level of lexical novelty in the rephrased lines in comparison with the similarity level. So to evaluate how well the generated lines align with the required beat pattern, we utilize 2 evaluation metrics. One is the exact alignment accuracy, where 0 means no alignment and 1 means an exact alignment. We also use the Levenstein similarity, which is more flexible to recognize cases where the alignment may not be exact, but still reasonably close. So we trained a baseline that doesn't attend to the beat pattern. So what we did is we zeroed the attention masks on the beat locations. We also used our previous model that was trained on the substitution task from the previous work as a starting point, as a form of curriculum learning to test if the knowledge learned from the previous task or the substitution task could be transferred to enhance the rephrasing task. This model, which we call the BR, so as a suffix, did better in terms of accuracy compared to the model that was trained directly from the BT5 parameters with 3+ points and more than 80 points compared to the baseline. We can see that the similarity scores are higher with moderate to low pink scores. It seems that our model tends to use words similar to those in the original lines as compared to the base model with higher pink score and lower similarity. Lastly, we performed human-centric evaluation. We recruited 20 participants for this study, comprised an approximately equal mix between native and non-native English speakers, as well as individuals with and without prior experience in poetry, lyrics, or music. So we start with beat alignment experiments, testing the substitution task from our previous work and the current rephrase task through word and line beat alignment experiments. These experiments assess the ability of our models to align words and lines with specific beat patterns while generating fluent and coherent text. For the word beat alignment, participants were presented with a pairwise comparison task where they were asked to fill in the blank with the word or phrase that best matches a given beat pattern. In a similar pairwise comparison setup, in the line beat alignment experiment, the participants were asked to select the line that best matches a given beat pattern. We also asked the participants in both experiments to indicate the choice that was preferred based on fluency and sense. For both experiments, we asked the participants to listen to an audio pattern, an audio beat pattern, and choose the best one that aligned with the beat. One of the options was the generated beat aligned output of our model, and the other is the original line from a real poem. The specified beat pattern was deliberately made different than the original beat pattern, but making sure that the number of beats in the audio presented to the participants match the number of syllables in the original. So we eliminate the possibility of merely counting syllables and matching with the number of beats. Here is an example of what participants may have heard. So I will now run a beat of like something that maybe like an example of what the participants may have heard. I'm not sure if it will appear, but I'll just run it anyway, then I'll describe it. So this is an example. So the sound of, basically it's the sound of a clave head that correspond to a beat and a pause for each rest. There is no tone or pitch change. The results of the word beat alignment evaluation indicates that human participants found the generated words with the model trained on the substitution task to align better than the replaced words. However, the fluency and sense evaluation showed a preference to the original words over the generated ones. However, if we also asked them to see if both of them are as equally as fluent and sensible, and in almost half the cases, the generated ones were preferred at least as much as the original ones. The line beat alignment experiment gives similar results. So to test the poetic qualities of the output of the rephrasing model, we needed enough context. So instead of a single lines, like rephrasing single lines, we rephrase complete poetry verses and test the poetic qualities as compared to the human written poems, which includes fluency, sense, meaningfulness, unpredictability, originality, humanness, and poeticness. We presented the participants with human written verses along with the automatically rephrased versions of these verses. We asked the participant to rate each of them from 0 to 100 on each of the qualities mentioned before. So we calculated the difference in mean between the human written versus the rephrase scores. Native speakers and experienced participants were more sensitive to fluency, sense, and humanness, rating human written poems higher with 20 plus point difference with statistical significance. The difference was less when we consider all participants. For poeticness, only the experienced group scores the original poem significantly higher. The other group seems to be debating it. For native speakers and experienced participants, the difference in meaningfulness, unpredictability, and originality hits marginal to no statistical significance, suggesting that meaningful novelty is debatable for them. So in summary, while the generated rephrased verses scored significantly lower than the original verses, on some of these qualities, they were still debatable on others. The difference in the mean range is relatively on the low to medium side on most of these qualities, which hints that the generated poems were somehow acceptable on average while maintaining a high level of beat alignment. So in conclusion, we presented parapoetry, a large-scale parallel dataset of poetry rephrased pairs, which we believe is a valuable resource for researchers interested in creative text generation. We demonstrate the utility of parapoetry by fine-tuning a pre-trained 25 model on a guided rephrasing task to generate lyrics line with predetermined beat patterns. Our results demonstrate that 5 model can successfully generate beat-aligned lyrical poetry with high rhythmic alignment while maintaining high semantic similarity. Human evaluation confirms that verses generated by our models align with the specified beats. However, evaluations based on fluency and sense consistently demonstrated a preference for the original text. This finding is especially noticeable in the qualitative evaluation, where native speakers and those with relevant experience rated the original verses significantly higher in terms of fluency, coherence, and other poetic qualities. So some of the limitation is that parapoetry was generated using GPT 3.5 and may contain inconsistencies or biases inherent to the automated process. Also, our current approach determines the beat placement primarily based on vowel onsets, so neglecting the impact of syllabic stress on the beat perception. And the human evaluation was conducted with a relatively small participant pool who are mostly not experts or self-identified expertise in the poetry, lyrics, and music fields, with limited set of examples. So in the future, we plan to investigate the impact of unstressed syllables on the beat perception and the precise locations and duration of the beats, using more human-curated data, expanding the evaluation set and the participation pool, as well as using this model as a tool to experts who write songs and ask for their opinion, whether or not this was helpful in a co-creative setting. Here are some of the references. Thank you for listening, and I'm happy to hear your questions.
Thank you, Mohammed, for this presentation. And questions? I have a question myself. If I saw correctly, because you moved rather fast through that slide, there was a slide about the participants, the demographics of the participants. So I would be interested to know, because in your results, I think those different groups of participants were not differentiated. So maybe if you could just comment on that.
I'm not sure, I did not hear all the question, but I will share the slide on the participant and maybe.
It was the slide where it said poetry, lyrics, English. So it was the slide about the participants' demographics.
This one?
The one human yeah, this one. Exactly.
Okay.
Yeah, I was wondering whether these are backgrounds of the human evaluators or their self-assigned expertise. And the question is, how does this play out in the results?
Yeah, so yes, it is self-identified. So we did not we can say snowball based on our knowledge of them. Maybe we know like some basic knowledge about some of the participants, but these results were actually selected by them, by the participants themselves. So it's self-identified. Now for the results, I mentioned here, and for example here, like we differentiate between the participants, and we notice that there is difference between, like all participants, people who are, like identify themselves as native speakers and experience only, and we notice that there is difference in the evaluation. Make sense? Is this your question?
Yes, yes, thank you very much. And you also mentioned that you plan to increase your pool of, yeah. I thought that the human evaluation part is interesting in your context because it seems like a non-trivial task. So it's good to see how humans fare in this. Questions from the audience? There seem to be no further questions, so thank you, Mohammed, again for the talk. And it would appear that everybody is ready for the coffee break.
Hello. A small change in our schedule. Instead of EBS concert at Casa do Lago, we will have the famous Festa Junina, June party at Unicamp. The link is already on the site, yes? And we will have live music and traditional food from Brazil, okay? And after that, we will have the conference dinner at Nono, Empório do Nono, with chorinho music, very traditional instrumental music from Brazil. Okay? You are welcome.
but I cannot due to unforeseen circumstances. I tudo bem?
Hi everyone, I am Jeba Rizwana.
Boa tarde,
Hi
tudo
everyone,
bem?
I am Jeba Rizwana, an assistant professor at Towson University in the US. I am one of the co-first authors
My name
of
is
Mosaic.
Alight. I am
Okay, welcome to this session. For various reasons, you have already heard 2 of the talks in this session, so good for you. So we've only got 2 talks in this session, 2 interesting talks though. The first is a long talk and the second is a short talk. So let's begin with the long talk. And you can see the title on the board here, Mosaic, Managing Optimization Towards Shared Autonomy, Authority, and Initiative in Co-Creation. By the way, this is the co-creation session, so we're very much on target already. And the authors are Alait Isaac, Jeba Razwana, and Kasper Hertveld. And I'm going to give over to the speaker now, and let's have an interesting talk. Thank you.
All right, thank you. So yeah, my name is Kasper Hertveld. I am from Norwegian University. I'm really happy to be here. I also understood this is going to be a longer talk because there's only 2 presentations, so I figured I might as well speak for 45 minutes if you don't mind. No, I'm kidding. I'm just keeping it to the 15 minutes. So this paper is a presentation. Some of you have been part of the secret workshop on Tuesday. We were actually doing a workshop around this paper. Now we're presenting the paper. It's not a secret paper. You can just access it freely. We are planning to do a secret workshop later around online, basically doing a follow-up around this work. But let's focus on the not-so-secret paper, Mosaic. And before I get started with this, I want to introduce both Alait and Jeba, because both of them are the folks who really have been pushing this work forward. I consider myself to be the cheerleader in this work, and happen to be fortunate to be here to present this work today for you. But those 2 are definitely the ones who have been doing the lion's share of the work. And now, all right, so the research team. So first we have Alait.
Boa tarde, tudo bem? My name is Alait. I am a 3rd-year PhD student advised by Kasper, who's presenting. I wish I could be there with all of you today, but I cannot due to unforeseen circumstances. I hope everyone enjoys the paper, and if you have questions, CC me alongside Kasper so I can answer questions and maybe feel like I'm there to answer. I might also be online, so there's also that. Goodbye.
All right, and then Jeba.
Hi everyone, I am Jeba Rizwana, an assistant professor at Towson University in the US. I am one of the co-first authors of Mosaic, where we explore how control between humans and AI can be meaningfully distributed and balanced. I truly enjoyed working on this project with my brilliant collaborators, Alait and Kasper. I wish I could be there with everyone in Brazil today, but I'm so grateful and excited that this work is being shared. Thank you so much, and I hope you enjoy the presentation.
All right. I also want to mention this has really turned out to be a Jeba session because the next presenter also involves a paper from her. All right. So let's go into the paper. So Mosaic, what is that? So the Mosaic is basically an acronym that is based on mosaic. And a mosaic consists of a lot of smaller elements that create a bigger whole. And that's basically what we're thinking about when it comes to our framework. Because when we're looking at the problem that we're trying to address, in this case, in this paper, is that there's a lot of terms that depict or describe how humans are interacting with co-creative systems. So, and what we're also seeing is that a lot of the literature is describing all these different kind of elements to eventually strike an appropriate balance between humans and co-creative AI. But there's a lot of things that people talk about, different kind of concepts that people are using. So you probably are familiar with some of these terms. Agency is thrown around, autonomy is thrown around, perception, communication, and then also, among others, initiative. So we were thinking about, okay, how can we see the bigger whole? You know, these are all these elements that make part of this mosaic, but we want to really get to the bigger whole. And what we did was we did a literature review, and what we found was that the real core element that we think is really important to think about that is control. So basically how humans are interacting with the co-creative systems, we believe control is basically a really important central component. And then when we're looking at that interaction, what we're really looking for is how do we get to the balance of control. And what we did in our work and the systematic literature review that we did, we were looking at characterizing, I have to, at a particular angle, yes. All right. Oh, it also works at the, okay. All right, there you go. Learn something new. So what we were trying to do is to really characterize control in co-creativity. So this is not a new problem. You know, a lot of people in HCI have been looking at this for quite a bit of time in terms of like, you know, how do you want to characterize this and understanding that this is like a really fundamental issue within HCI. And, but we again wanted to focus on this notion of control, which we define as the power to determine, initiate, and direct the process of co-creation. So this is about who's initiating, leading, deciding, and navigating the process of co-creation. So as part of our research, we had a couple of questions. You know, one of them is like, what are the key dimensions of control? Because control is the overarching concept, but we wanted to understand what are the aspects of control that make part of it that are important to understand for us to consider. And then we wanted to understand too, how can control be balanced between humans and AI in co-creativity? So that was our effort. I already mentioned that what we ended up doing is this systematic literature review. So how we went about doing that, we first did a preliminary literature review where we looked at the literature ourselves and tried to understand like what are the kind of key phrases that are an important part of it. And what we find is that when it comes to control dynamics, there's so many different ways that you can look at control dynamics. So eventually we came up with two different buckets to look at the conceptual role of control dynamics. One pertains to the dimensions of control and the strategies to balancing control. But then the other, we were looking at the factors that influence or are influenced by control. And in that way, we try to look at all the elements. So again, mosaic, you know, there are all these different elements that make up the larger whole. We were really trying to understand, you know, what are all the key phrases and the key elements that are part of it. Okay, so here you can see all the words that are part of it, and to make sure that we did get relevant literature, we did preface that all with human AI co, or a mixed initiative co, to make sure that we would get literature around co-creativity, because our purpose was to look at co-creativity literature. And then we also added, because we found that important, to add some broader AI domain keywords to make sure that we really cover and that our search is completely comprehensive, because we found that some papers were still being excluded. So this is basically our process. That ended up leading to 172 papers that we selected. We only looked at two databases, so the ACM Digital Library and the database of the Association of Computational Creativity, which is obviously associated with this conference. So looking at the literature and understanding what really is going on, this is basically where the framework emerged from. And this framework, MOSAIC, stands for Managing Optimization Towards Shared Autonomy, Authority, and Initiative in Co-Creation. So what is this framework? I won't keep this a secret. So this is the framework. It's a 3D plane with 3 dimensions: autonomy, initiative, and authority. And for each of the dimensions, there's basically 3 different elements to denote where in the dimension things are happening. So there's the full AI part, there's the shared part, and there's the full human part. So on the bottom left, you can see full human control, so the AI doesn't really do much. And on the other side of the spectrum, we've got the full AI control. And I'm sure some people in the room feel maybe somewhat uncomfortable about that possibility. But that's basically the whole plane from the 3D plane. Now you can also look at the plane in a 2D side. So you can just basically take a slice of it to look at 2 of the dimensions and also understand within those 2-dimensional plane where basically a particular co-creative system sits. So let's go into the 3 dimensions that are part of MOSAIC. So the first is autonomy. So autonomy, what's important with that is some people in the literature refer to this as agency. We chose for autonomy because agency is a much higher level concept. It's also has a lot of different definitions and understandings, and we figured autonomy might be a better concept to work with, which we defined as refers to the ability of the agent to choose its creative action. So when we're looking into the literature in terms of how autonomy is being optimized when it comes to control, we see that one important aspect is that we need to mediate the extremes. We don't want the AI to be fully autonomous, but we also don't want the AI to do nothing at all and not be able to choose any creative action. So we need to mediate the extremes. That's what the literature is saying. Hmm? Yeah, I'll use the bar. Yeah, that's fine. Okay, thank you. What's also important, what the literature shows, is what also is important is that the AI has a particular level of autonomy, and if humans perceive that there's a particular level of autonomy, its creative input is also much more appreciated by humans. So that's also important to kind of think about, that there needs to be some level of autonomy in terms of it being appreciated by humans as they're interacting with the co-creative system. And what's also important in terms of this balance that we're talking about is that the literature shows that when there's situations of shared autonomy, it really enhances the team performance. All right, initiative, that's basically the second one. That refers to the ability to proactively contribute to the creative process. Here too, there's a couple of aspects that the literature emphasizes. So one is that it's important to shift the levels of control in this case. So sometimes somebody takes initiative, the AI takes initiative, then the human takes initiative. It is also important that there's mixed initiative control. What we mean by this is, for instance, that there is a situation where the co-creative system is not waiting for the human to respond, but can actually take initiative. But there are also situations where the human is able to see the progress that the agent is doing and also is being able to monitor its intent. So there's this notion of mixed initiative control necessary, which is primarily mentioned in the human-robot interaction literature. And then related to the first item is that there is this important to really foster turn taking. So sometimes the AI is leading, sometimes the human is leading, and then the other is following. So authority. Authority sometimes in the literature is referred to as control, but here control we see that as a higher level concept, and this refers to the extent of decision making or directing power that shapes the creative process. So here what the literature is saying is that it's important to adjust to users' preferences and expertise. Particularly what we're thinking about is, for instance, experts, they kind of see the AI more as an assistant, and then the AI has a little less directive control. But if it's novice users, then the AI might need to have more directive control. What's also important is to be attentive to the creative experience. If the AI overrides the human intention, that might create a negative experience. This has been particularly noted in the game design literature. So that's also important to kind of consider. And some sort of regulation is also important to think about the different roles that occur throughout. And what we see here too, and what the literature is suggesting, is that shared regulation, where basically the AI and the human are both kind of regulating the process over who is taking authority, is a really promising direction. So what's important is now we basically looked at the dimensions. So what are the strategies for balancing control that we found from the literature? We basically extracted two main aspects. One is AI-controlled adaptation, and then the other is human-controlled configuration. And as one may expect, okay. No worries at all. Okay, so there's the AI-controlled adaptation. So yeah, what you think about here is that basically the AI is changing what the control is between the interaction between the humans and the co-creative system. So you can think about adaptive autonomous systems where based on the task, the AI is automatically changing what it does. And then the AI could also potentially estimate or detect the emotion or the cognitive load from the user, and based on that, changes the way that it's interacting with the user. And on the human side, you can think about customization options, you can think about sliders, all kind of ways where the human decides kind of what level of control is happening. So Mosaic, we wanted to also, as part of the paper, kind of see how we can apply that. And what we did was we grabbed 6 case studies of co-creative systems in different domains, and we tried to kind of understand, you know, if we apply Mosaic in terms of its 3 dimensions, can we get more insight into how these co-creative systems look like? That's all more on the table, so this is all revealed, and people can look for details in the paper. But basically, this is what that looks like. And as an example, here's one case study about Cyborg, which is a system where an LLM is interacting with an actor, and the actor basically takes the initiative. That's why it's full human when it comes to initiative, and it's also full human in terms of authority, because the human decides as part of the acting whether or not they're going to follow through on whatever is provided by the AI. And that makes it also very much human controlled. So discussion around this work, you know, just to repeat, you know, we introduced basically a new framework that is trying through shared autonomy, authority, and initiative to basically create and look for the balance of control. And what we eventually want is basically a harmonious co-creation, which is described here. Mosaic can be applied in a couple of different ways. You can look at it to be able to analyze co-creative systems, specifically around control. You can also look at it to be able to think about how can you configure and customize an existing co-creative systems, or obviously you could use it to actually design your co-creative system. There's the obvious limitations, which is that we only looked at 2 different databases. There's also a lot more to be considered. You know, as part of our search, we did look at factors such as trust and ownership. None of those are part of the framework, and we're currently thinking about how we can expand on that. And in terms of this expansion, you know, there's still a lot of questions about how do we really deal with control dynamics? How do you really design for, you know, co-creative balanced systems? So there's still a lot of questions around that, as well as about the practical applicability of Mosaic, which is why we've been running these secret workshops. So this is a Mosaic in Rio. I was able to visit myself, fortunately, a little bit before, and I looked at the smaller elements. I really encourage people to do that because the whole is really nice, but the smaller elements are also really nice. I picked up a little Dutch, because I'm from the Netherlands originally. They're in the middle, so that was a really nice surprise and an aspect to think about. So look at the small elements, but also consider the whole, and Mosaic is able to potentially have you consider what the whole looks like. So that's our purpose. We are continuing this work. As I said, we continue to want to run some more secret workshops. So if you don't want to miss out on those, feel free to ask me and come join us, or ask Allied or ask Jeva. And I think it's time for questions.
Yes, indeed, we have time for questions, and over here we have...
Yeah, nice talk. So I'm wondering, when you talk about control here in human-AI collaboration, how does that work? Whether you think that concept is different from human-human collaboration, say I'm collaborating with an expert from a different domain?
I think that's a really interesting question, to what extent like human-computer interaction maps onto human-human interactions. I think here the difference is basically the fact that we're dealing with an AI and what we feel about that AI. You know, like when you're, obviously trust also plays a role when humans interact, but I think it does have a really different connotation when it comes to humans and humans versus a human and an AI. So I think some of these concepts just have a different meaning and interpretation, but I think there's a lot that we can learn from basically, you know, how other practices work. And as a matter of fact, you know, Allied is doing some of her PhD work, even just thinking about how photography or video art, what we can learn from that for building AI systems. So there's definitely similarities that we can learn from, but there is the particular difference about what AI systems are capable of and how we view AI systems. Yep.
Thanks for the talk, really interesting. Given that a lot of literature with human AI anything is basically one human and one AI, and then, you know, turn all the knobs and levers to vary how they interact, but work in the real world is often multiple people or multiple systems or otherwise. How do you think that, I guess, the Mosaic perspective changes or evolves to think about groups and compositions of those groups in the sense of many people and an AI, or many AIs and a person, or many people and many AIs?
Yeah, that's actually, both questions are really wonderful. So yeah, I think in that case, it depends on what the role of all these different AIs have and all the different humans. I think you can still classify them, but it obviously is going to change the dynamics. And I think I will need to think a little bit more about that. But in general, I'd say you could still apply the different dimensions, because there's still a question for each of those different AIs, like what kind of authority do they have, what kind of autonomy, do they all have the same, are there different roles within that process? So I think you could still use Mosaic to sort of classify the team dynamics, but I think what is really interesting here is like what emerges from it all, right? So if some have low authority, and some have high in terms of the AIs, what does that mean for the dynamics that then evolve? And I think that's a really interesting research area.
Thank you.
So we have time, Dan?
So I thought of a completely different thing when I read your title, and I thought about the optimization part. And when I think about optimization, I think about an objective function, and we're climbing up to the top of that objective function, which may or may not be the way you're thinking about this, but I'm wondering if you have any thoughts about what would an objective function look like in this framework that you would optimize. And maybe even the second part, which I think is more interesting, is if you picked a point in that space, that framework space, could you say anything about the inverse problem of what objective function gets you to that spot? Is that an interesting question? Is there any way to answer it?
Yeah, absolutely. I think one part that we first need to understand is obviously, that it's context dependent, that maybe in certain circumstances you don't want to have shared autonomy and shared initiative and things like that. So there needs to be a way to recognize what is good, but especially I think what the aim is to be basically have such an objective function would be really great, especially when it comes to dynamic situations, right? Because we talked about a couple of ways to sort of like balance the control is to do that adaptively. And if you want to do that, you need to have some sort of objective function or ability to detect what would be desirable in a given situation. So I think that's something to work to. We haven't really got around to that or really thought about that at the moment. This was basically just our conceptual effort to kind of really think about what we want to do, and that the literature suggests that this shared aspect of it is what's ideal, but obviously it's not ideal in all circumstances. So working towards thinking about, well, how could this be translated to objective functions that then can be implemented in adaptive systems, I think is a really great next step. So it doesn't fully answer your question, but it spalls towards like future work.
Thank you.
Any other questions?
Thanks. To some extent, it probably relates to Dan's question a bit, but is there a danger potentially that because we have LLMs that can do a bunch of stuff, in inverted commas, right, everything from coding to language things, etc., that when we're thinking about creativity, we condense a lot of things that are very, very different. So, the case study, so you've got dance, there's writing, etc., and that might lead us towards potentially some, not necessarily incorrect conclusions, but conclusions that are challenged by being too broad. Because I suppose part of my concern is that, to Jan's point about an objective function, what that could look like for dance versus music versus writing versus whatever, that we may set ourselves up for an impossible task. So it's more, I suppose, a speculation than anything, that is there potentially a danger because LLMs are so, or AI is so general, that we're folding a lot of very, very different creative situations into one space, and that could be problematic.
Yeah, absolutely. As I mentioned, I don't think there's necessarily a blueprint to say that this is how it needs to happen. I think there are two ways to kind of look at Mosaic. One is to say this is a conceptual framework that helps you understand how to think about co-creative systems and what dimensions to consider, as a designer, as you're thinking about this. Because a lot of the times we may unconsciously do certain aspects and say, like, are we actually granting too much authority to the AI? And specifically in all these cases and domains that you're talking about, let's think about what is appropriate for dance, for poetry, and for all those other cases. So I think one way to kind of look at this Mosaic framework is to say, yeah, it's a conceptual framework for us to kind of critically think about how we design our co-creative systems. And the other part is, okay, is there a way to operationalize and create actually functions that allow for adaptive systems to potentially take place? But what it now currently really is that conceptual framework for us to really think about how to think about co-creative systems. So there is not necessarily, and I think that's maybe the optimization part, right? Like, we're not necessarily saying this is how it ought to be, but basically saying, this is a framework for you to consider as you're designing these co-creative systems.
Okay, so some excellent discussion there. Let's thank our speaker. And was announced, the next talk is a related talk, so let's welcome our next speaker. Okay, so the next speaker is part of a related paper. The speaker is Giancarlo Caloca, and his co-author is Jeba Razwana, the co-author of the previous paper. And the paper is titled Prompting AI in Co-Creation, the Role of Syntax and Sentiment in Shaping AI-Generated Content.
Hello, everyone. I'm Giancarlo Colloca, and I'm from Towson University. And today I'll present this paper that I wrote in collaboration with my PhD advisor, Dr. Jeba Razwana. We investigated the patterns of user prompts in terms of syntax and sentiment, and how they are associated with AI responses in creative storytelling. So our main motivation was focusing on storytelling. That is a domain in which generative AI is transforming creative collaboration, and where the understanding of how users write prompts and their influence on AI responses is still limited, which is a key to improving AI responsiveness and enhancing human-AI co-creation. Based on these gaps, we investigated how do users write prompts in terms of syntax and sentiment, and whether prompt structures influence AI-generated content. Understanding this dynamic is important to help us design co-creative tools that are more intentional, transparent, and empowering, allowing users feel in control of the creative process. So we recruited 100 participants through Prolific, an online platform for participant recruitment, ensuring a diverse sample. And we designed a simple storytelling task using ChatGPT. So participants were given the beginning of a story with a girl named Alice and her dog Lola, and they continued the narrative and prompted ChatGPT to finish it. So the data we collected were about the screenshots that each participant provided, and both the screenshots were involving both the prompt and the AI's response. So we analyzed this dataset using several tools and methods, starting from parts of speech tool, tagging. We used parts of speech.info, that is a widely known tool based on NLP. And we labeled the syntactic functions of every word using these 9 tags: adjective, conjunction, determiner, noun, prepositions, pronoun, and verb, and numbers. Yeah. And then we applied k-means clustering with principal component analysis to identify stylistic patterns using the post tags as cluster features. And the other part was involving sentiment analysis, and we used text-to-data, a widely accepted tool that helped us score the emotional tone of text in a range from -1 to +1, considering neutral the scores between -0.25 and 0.25. And finally, we used some statistical tests like t-test, ANOVA, chi-square, to see if there were correlations between the user prompts and the AI responses. So, in general, we found that ChatGPT's responses were more descriptive than user prompts, but in particular, two main styles emerged in both prompts and responses. We observed a cluster 0 that included more expressive text. More expressive means that these participants or these responses used more pronouns and adjective and adverbs, and suggesting that this was a more personal tone. And in cluster 1 was represented by more descriptive text with more nouns and determiners, reflecting a simpler and clearer structure. So here we see the clusters in prompts and in responses. And while we could observe this distinction clearly in both prompts and responses, no correlation, no significant association emerged between the prompts and response clusters based on these syntax structures. So this finding is somewhat unexpected, as one might assume the structure of user input would influence the syntactic style of the AI output. And we also found no significant associations between the prompts response clusters and the participants' demographics. So about the sentiment analysis, something striking was revealed by our data, by our results. In particular, in the prompts, we observed 44 positive prompts, 23 neutral, and 29 negative. And in the responses, there is not this kind of distribution. And in particular, we see how we had only 5 negative responses from ChatGPT. When we analyzed the shift trends in nearly half the cases, ChatGPT increased positively. So even if a user introduces frustration or sadness, ChatGPT often responded with emotional uplift. These patterns reflects strong tendency towards positivity amplification. So these results raise a critical implication. If AI tends to flatten stylistic and emotional diversity, where does our depth end? And also, the sentiment modulation risks erasing emotional nuance, and an issue that is called AI homogenization in creative domains. So we asked ourselves, if AI usually smiles back, what happens to nuance? And third, if AI doesn't truly listen to our tone or style, what role do prompts actually play? And do prompts reflect authorships or just trigger automation? With these results, we can conclude that our findings revealed a gap between user intent and AI output. So future work should address this by exploring different creative tasks, also in domain other than storytelling, designing and investigating longer interaction cycles, considering the range of types of sentiments to better understand how emotional tonics is expressed, transformed, or constrained in these interactions. And also developing adaptive systems that adjust their tone based on the user style to support richer and more user-centered co-creation. And last, investigating how we can better understand the associations between prompting patterns of users and the creativity of the co-created output. This is a direction that we are already pursuing currently. So yeah, this is what we plan to follow up. And I thank you for your attention.
Okay, yes, we have a question off the bat.
Giancarlo, thank you for the presentation. Very striking questions from the reflection, and there is really nice to explore these things there. But I was wondering if you find any structure in the prompts of the users. For example, did any of the users use a role representation? For example, you are a helpful assistant, or you are something. And if there is any kind of direct instructions, because if you directly instruct them, the LLM, not to be positive, it follows or it doesn't follow? Is there any kind of template that you use to?
This was not included in the task. It was a simple task in which the users just asked ChatGPT to complete it with 3 paragraphs. So in the task, we gave a limited time for completing the story, and also a limited number of paragraphs, and users didn't ask to use a sentiment or another one, or it was not in the task.
Okay.
Any other questions?
Great talk, really interesting stuff. I think the twofold question, I guess, in one sense, are you going to look at future work in terms of comparing different LLMs to see how much a positive uplift you get for each LLM? And also, is there a way to, echoing the last question, is there a way to actually make it more depressive, if you were talking about this kind of thing? Is it possible to make it, if you're writing a dark story, can it also then do something darkish in the things, even if it's not like a mental health type darkness? You say we're writing a horror story, for example, could it also write a horror story which was also dark as well? Or is it going to do a positive uplift in those kind of things?
Yeah, about the comparison of more LLMs systems, that's something that we are planning to do in future. And the second one...
but in terms of with the positive uplift every time, or the response, is that, can you force it to do a negative turn?
Yeah, we didn't explore that in this study. That always was overall it was based on ChatGPT 3.5. But using more recent systems, and maybe also training some of these systems will tell us if what we expect to have more user-centered responses will be possible also in a negative direction. That's what in arts we would like to be helped to express, not only positivity.
Thank you. That's good.
Thank you.
Okay, I have a question. Actually, it relates to the first question. And I don't have a question. Someone else has a question. Okay. Oh, okay, very briefly, it was mentioned about system instructions as being distinct from prompts and how they can change the personality of the language model. I wondered if the prompting that you're using, you mentioned authors as exemplars for styles. So asking for a story in the style of H.P. Lovecraft or Franz Kafka or H.L. Mencken would considerably dampen the mood of the story. And without necessarily introducing tone into the prompt, you're you're introducing a pointer to tone, which is different.
Yeah, that could be a possibility to set some controls in a direction or in another one. That's what future works could explore, and maybe realizing developing new systems in which the user interface is more available for setting different structures, different directions.
Great talk. Can I see the slide with the clusters again?
With what?
The clusters, the clustering.
The clusters.
My question was simple. How did you decide that there should be 2 clusters rather than 3 or 4? Because they're pretty close to each other.
We use different methods for reducing the dimensionality that was in 9 dimensions, and in this case, at the end we chose PCA, and for identifying 2 clusters we used the elbow method that showed the best number was 2, and we were quietly satisfied with these clusters because they are very distinguished,
very
separated.
explainable.
Yeah.
Yeah. Okay, that's my question. Thank you.
Thank you.
Any final questions?
All right, thanks for your talk. So, quick question. It seems to me that this bias towards positivity from these LLMs comes from the reinforcement learning from human feedback that they're fine-tuned afterwards, right? So I'm wondering if you have considered, actually it might be more than a comment than a question. I think it would be interesting to experiment with LLMs prior to this reinforcement learning of humans, because they are probably the most responsible for bringing this positivity. Also because these are corporate systems, so they don't want this to be negative, right? So I think if you train your own system or your own LLM, or it could be smaller, but you could at least check out how much the system would become more positive after this reinforcement learning part, right? I think because during this reinforcement learning part, humans normally are encouraged to be more positive, right? So it makes sense that the system is being positive, I think. It's kind of expected in a way. Do you have comments about that?
Yeah, we think that the policy of this system, as well as other systems, influenced these results. But we put ourselves, how to say, in the shoes of the average user that just maybe want to create a story in few minutes or in few seconds, and we would like to have a system that resonates, that is how to say, also mirroring, no? Because if I ask you to work something with me, to write something with me, I expect you to understand that I still want to be considerate. My style should be considerate, no? And for sure, the policy of ChatGPT is probably the reason why we had these results. But it was what we wanted to explore, to have statistics and numerical data proofs that this is a limitation of this system.
Okay, thank you.
Okay, let's thank our speaker. In fact, let's thank both speakers for this session.
Thank you.
I guess we have some free time now, and there's music in the car park at some stage. Darren? No?
What we should announce is that there's a conference banquet tonight. Yeah, come on. There's the conference banquet tonight at 8 o'clock at Casa del Nonno or something like that. The same... Emporio de Nono. If you were here Monday for the welcome, it's the same place. If you were not here Monday, like I wasn't, then use Google Maps. Yeah, I think it's walkable, but it's a long walk, so you might consider Ubering it at least in one direction. It starts at 8 o'clock. It should be great. I think there's music involved there somehow, but I don't know. And I think there's also food involved there. And until then, I guess there's free time to frolic about the facilities or something. I don't know. What? I don't know about a car park party, so I'm going to have to turn this over to somebody who knows about that.
Yeah, people in the car park know that. By the way, did you hear that, Raphael? Okay. By the way, I think no means grandfather in this context, right? It doesn't mean no, don't go. So please do come tonight. I'm sure it'll be very nice. Okay, so as Dan said, go frolic and cavort now for a while, and we'll see you at 8 o'clock at Emporio de No. Let's thank our speakers one more time.